I really did just kind of just jump in with no people on. That's my own fault, though.
People will show up.
Oh, it's got pretty low latency, too. I actually can pull myself up on YouTube and see. Oh, I got someone in here.
It's you. You just pulled yourself up.
No, I got someone else in here, too. Oh, that's cool. Some people are kind of joining. This is going to be kind of a interesting one. It's going to be one of those things where I have to kind of wait until people start filing in before I can actually start deciding on what I want to make for the stream. But I guess while I'm here, I can kind of show off some of the stuff I have.
Can I hear you?
Yeah. You can pull it up on YouTube and you can see. But I might as well show... I can show some of the stuff that's on that I already have pre-made. Basically showing like what's going on with them.
Can you see your chat?
Yeah, I can see chat. CNY Siren Boy says hi. So I got a couple people in here.
Gotta realize you talk to the people, not
I know, not just you. It's kind of embarrassing. I'm just doing stuff myself. Well, I got people actually watching now. But I might as well go ahead and get rid of this analysis so people can actually see what this is. I don't know why that little piece was there. So let's pull up a couple other sirens I have that are basically already done to give people some ideas as to kind of what I can work with here. So I know a couple people, for example, were wondering how I managed to actually get a rotator into the 500 SHTT. So here's what that siren looks like kind of all together. I'll get rid of this analysis, but there's the 500 SHTT, the one I did a video on a little while back. Now, I know that people were curious about how that rotator worked, so I'll go ahead and actually just take this apart. So you can see kind of what's going on inside there. So the motor mount sits basically right in here, and then I have the entire gear drive right here. This right here is actually the rotator motor. That's basically just a small little gear motor that you can get off of Amazon, pretty much. But that's how that rotator works. You can see that it's not actually being driven off of the main motor shaft. But that's one of them. Go ahead and reassemble that. I like keeping all these things on analysis so I can just see, basically as a cutaway of how it looks. What else do I have on here I can pull up? Oh, I forgot I have the... People haven't seen this one yet, because I haven't... Well, they've seen it on my old video, but they haven't actually seen it now. I've got the SD10 as well. But that's not what this video is basically going to be for, the stream is going to be for. This is pretty much going to be making some new things. So if anyone has some suggestions as to some kind of siren they would like to see me design, something that's reasonable enough that I can do it within a reasonable amount of time. So I'm not like designing like an AC-8 Hurricane or something that's really complex. If anyone has any idea. A P10. Okay, doing a P10, so an ACA P10. I could probably definitely do that. Well, I mean, P10, P15, basically the same general series, but yeah. What kind of port ratio though? The standard 912 or 8 port, which I know wasn't very common. Cyro drone? What do you mean, man? I got a Cyro drone right there. No, I'm just kidding. That's just the Mach 7. You guys can probably see the tags up on the top. That's what the inside of that looks like. Bless you. 912. Yeah, I could probably do 912. That's not that hard. Darley STH10. That'd be an interesting one.
You can
Yeah.
do a poll.
I could also do that as well. I haven't done any Darley stuff. I was gonna make a Darley Model 5 because I have in my files over here. I'll pull it up really quick. You can get a look at it. Because I have the Model 7 model right here, and one of the things I very easily could have done is just come in here and actually just change the cones. And it would have been very easy to just go ahead and make this like a Darley, with very little editing. But that's the inside of the Model 7, which I know a lot of people have also seen. It's one of the ones I was selling on Etsy for a while. It had the wrong intake tube on it. Oh, I still have the wrong intake tube on it. I've made multiple parts for this siren in the past, so things are kind of confusing. There we go. So I got a couple things people are requesting. I have an ACA P10, I have a HOR Cyro drone, STH10, a Darley STH10, or a Banshee. Hey, the Ray 2009, thanks for joining. One of my most active active members of my community. You seem to always jump on when I have a post out. But yeah, I got quite a bit of models in here. So I got this one people haven't seen, though they've seen the very first version of it. This is the SD10. I've actually got the prototype printed out, but I haven't actually assembled it entirely yet. There's the 500 cutaway, and then there's of course the STL10. And then the Mach 7. I got a lot of people coming in chat now. Got up to 8 people now. Surprising. I didn't think a lot of people would actually be interested in joining. Just because I know that, like, I originally said 7, and I really had not thought about how difficult it was going to be to actually get the stream kind of up and running. But consider this the blank canvas, if you will, for whatever ideas you guys have. But yeah, more suggestions. If you guys have any other ideas for different types of sirens, go ahead and just put it in the comments, and or in the chat, and I'll go ahead and look through it. So far, we're up to about four different ideas for what people were kind of looking at. It would be kind of nice to break out into doing some ACA stuff, because I've been pretty much just sticking around Federal. Those Mach 7s are actually 912, even though they were regular 12-port Model 5s in the system. Yeah. Yeah, this Model 7 right here, the flattened Model 7, this is just using... Let me go ahead and get rid of this analysis so you actually can get a look at it. And I'll get rid of these cones. But yes, the Model 7s were actually the Mach 7s, I should say, just to kind of clarify between the different types of models. Yeah, they were 912, which this was a discussion that Eden and I kind of got hung up on, because we both climbed them because we were trying to figure out exactly what they were. And why they were flat. I mean, we knew they were Federal codes because they said Federal code right on the side. But we wanted to get a look at the chopper and actually see kind of what was going on with it. But they have so much screening around the actual lower half of it that you actually can't really see that much in there. Eden did eventually get a pretty good picture of one that was, I believe, on top of a fire station somewhere in Los Angeles, that they actually had taken the entire thing and flipped it upside down, so that you can actually, they moved the housing, so you actually could see the ports on it. But it's just odd seeing that it was a federal code siren, which means most likely single tone, because sirens, of course, up until that point weren't really double tone. And then, but then it being a dual tone siren 912, which was only instated in like 1952, is what the community has kind of agreed on, because of an old SD10 advertisement where it says that, like, oh yeah, due to new civil defense regulations, they require sirens to be dual tone. So it's kind of a mystery still as to why exactly they are 912, if they were converted later, or if that's just the way they were specially ordered, or if that's one of Federal's very first dual tone models. I don't know. It's kind of an odd one. But yeah, they are 912. This was just a kind of a placeholder for when I first modeled it, because I already had this stator basically made for when I made the regular Model 7s. Let me go ahead and get rid of this. So yeah, but that's the Model 7's rotor and stator. That's for, I think I actually have it pulled up on another model somewhere. Yeah, okay, I have it pulled up over here too. So basically, I made this as a separate model. Whoa. Hold up for a second, I gotta move a whole bunch of stuff. I got so many tabs open now. So this is the flat Model 7. I mean, as you guys were able to see before. But this basically, I literally just took the same model that I had of the Model 7 and I just shrunk it down. So originally I used the same rotor and stator as this Model 7, and then I eventually just took that, and then I wanted to make it dual tone. So I actually just took the chopper. I have it set as its own separate entity. So I initially took, this is my very, very first dual tone rotor and stator, and it looks like my first, because this is basically going off of just pictures before I eventually got my own SD10. But pretty much I just took this model, which of course is shared across the SD10, it's shared across the 500, and I just shrunk it down a little bit to fit it inside of the Mach 7. So now I actually have a flat Mach 7 as well, that I have a flat Mach 7 that also has dual tone. Sorry that I'm kind of like jumping in between what I'm looking at. I got a lot going on here. Gyroscopic gaming. Did I see a siren that looked like an 8-horned Thunderbolt 1000T? That siren is SoCal Edison. Oh, you might have been, yeah, that siren that you were seeing on the, don't save. It's just giving me these, Fusion always does this. Yeah, that siren that you were looking at, that's on the thumbnail for the video, is actually, it's somewhere on here. Let's see exactly where it is. I know I have it on here somewhere. But yeah, I have that on here. Oh, I just got an Xbox notification as well. Don't save. This is the 500 again. Where are my other documents? Where are my other documents? Interesting. So it's only pulling up my editable stuff right now, whereas I should have some other things I've just basically made invisible. It's odd that it's not pulling those up right now. Oh, that's why. Okay, so I've got a couple of things that I've got modeled here. So this is another thing that people probably haven't seen yet, but this is because this is like one of the little things I was kind of playing with myself. But I did make a B&M I modeled this a long time ago now. Originally, I modeled it as one of the friction-driven sirens that B&M used to have for like motorcycles. I even have it right here. I printed it in yellow, of course, but of course that spins. But no one has seen this on my channel because this is basically something I made for my own entertainment. Pretty much, I actually had it mounted to a scooter, and I used it around Los Angeles because people don't listen to bike bells. Yeah, but the siren that is in the very front of as in the thumbnail, that siren is, where is it? There's the Whalen. I think it's really, really far down on my, there it is. Yeah, there's the Model 120. So a lot of people have seen have seen this. This is pretty far back in my channel. This was before I had the GoPro and I was able to edit videos really well. But this is the Model 120. I know a lot of people before, when I actually released that video, were also asking what the Model 120 actually looks like on the inside. So I mean, I guess now if I have some time, I probably can go ahead and actually just show you that right now. But yeah, that's the Model 120 model. So let me go ahead and split that in half. Do I have analysis set up for this still? No, I don't, because it's set for edit view only. I have to go back. Don't save. Hold on. Let me just go back really quick, make this editable so I can show you. Okay, I'm using the not paid version of Fusion, so it's kind of hokey with how you have to like run around and avoid having to pay for anything, because I do not have $700 just laying around for that kind of stuff. So let's do a section analysis really quick, and I can go ahead and show you what the inside of the 120 actually looks like, which is may or may not be interesting to some people, but this is basically a cutaway of the 120. I can back this up a little bit so it looks a bit better. Ooh, wow. There we go. Alright, so that's a cutaway of the 120. And it just went away. There we go. So I know the inside of the 120 is a little different. Yeah, so you say, why does Aaron's Model 120 have a 4-port rotor and the 3D printed one has a 5-port? So the one that Aaron has, Dude Rocks, on, for those who don't know, Dude Rocks 5539, I believe, is his channel name. Yeah, his Model 120 was a prototype 120 that wasn't ever in service. So it was never actually put up or anything like that. But at some point, when they eventually started finalizing the Model 120 to actually be put into service for San Onofre, they did end up changing the rotor to be a 5-port rotor because they wanted it to be somewhat atonal, because having 8 stator ports and then an 8 rotor ports, you ended up getting anti-waves, because as the rotor spins around and pulses out of 4 of the horns, because there's only 4 ports on the rotor, you're limited by what your rotor can actually let through. By having those pulses come out 4 horns and then have it rotate about, what is it, like 20 degrees, and then hit the other 2 ports, so another set of 4 horns. As the pulse is still leaving the first horns, you have another pulse now coming out of these horns, and they end up actually canceling each other out. So you actually end up bringing down your volume output, because you basically have the 2 waves canceling each other out. So, which is why they added 5 ports to make it atonal, so it wouldn't do that. But yeah, this is the inside. So I'm going to kind of point with my cursor here as to kind of what's going on, because I know that, like I said, there's not very much. People haven't seen really a cutaway of like what the 120 actually looks like. But right here we have the blower down below. So I model all this. This is the actual Paxton blower. As you can see, there's the impeller that's actually moving the air through it, and it is channeled through the inside of this volute right here. I don't actually have this thing being bell driven, because there's really no use or no point for it to be belt driven at this scale. I'm not trying to get this thing like supersonic. But so the air basically just gets compressed, or I should say concentrated in here, and then it's forced up this tube, which this tube is actually designed with a purpose in mind. It's not just tapered just to fill up the space and eventually make it bigger before it gets to the rotor. This tube is actually tapered like that because, as many of you know, sounds come out of a siren in both directions. They come out radially around the ports, and they also come out axially out through the front of the horn, or the air intake, I guess you can say. And because the designer didn't want a whole bunch of that noise being fed right back down the tube and coming outside the blower, this tube is designed basically to act as a resonant trap, so that as the sound waves are pulsing from the top of the rotor going down, I guess you can't see my hands. I'm trying to like motion with my hands, but you guys can't see it. But as the sound waves are pulsing down from the rotor, they're gradually being constricted more and more and more right around here, to a point where it's basically acting like a reverse horn. So the sound doesn't want to travel down the throat of a horn. It wants to travel along it. It wants to follow the expansion. It doesn't want to go backwards on a horn. So the sound basically gets caught here and stays within this general area. And then up here, this is the actual air diffuser. So if you were to follow the air path that the air from the blower is coming from, it's passing up basically directly through here. It's a really awesome design. Let me look at the chat a little bit more. So we got a lot of people kind of coming in here now. So the Ray 2009, yeah, LOL. Everyone's saying Cyrodrone, even though it's freaking Federal Code Model 7. Yeah, it literally says Federal Code on the side. I don't know how people were getting that confused. Try 3D printing a rotational bollard. That'd be an interesting one. That would be an interesting one. Love to see an STH-10 in the future. Yeah, wow, the inside of the Model 120. Yeah, that's it right there. That's what everyone's been wondering about. But that's modeled after the actual blueprints. Consolidation 1282. I've been watching your videos since the Model 120 video was uploaded. Never thought you would do a live stream. Yeah, I never really thought I was going to do a live stream either. But I don't know. I thought it'd be kind of a bit more fun to interact with the community that way. How long did it take to print the Model 120? The Model 120, each horn, just the horns itself, each horn took about 14 hours to print for just a horn. And since there's 8 of them, it took a really damn long time to print, trust me. The Ray 2009, can we see the 4.5 Thunderbolt files? Yeah, definitely. Definitely, I'll pull that up. Let me get rid of the stuff I'm not using right now. So I'll get rid of the STH10 or the STL10. So yeah, where is the? It's a circumscribed horn. That's relevant to Fusion because Fusion is very specific with their terminology. Let's see, where is it? Where is the Thunderbolt? I have a whole bunch of like really stupid models on here. I didn't realize I have to clean up my Fusion a little bit. Yeah, there it is. Oh, it's read only. Hold on, one sec. Let's fix that really quick so you guys can actually get a look at it. Fusion's having a bit of a heart attack now because I've got so much stuff open. Yeah, let's close that for a second. Let's make this. Let's make this so I can play with it a little bit here. Now it should be loading in now. It usually takes a second because Fusion is just running on a laptop, so it does give it a few seconds. Come on. Oh yeah, there's a lot of entities that are used for the Thunderbolt, so it kind of takes a little bit to load it all in. Sirens and Aircraft, hello, hello to you. Triblaster says, "Oh, I didn't know the Model 120 had a special way for the sound going down the intake." Yeah, basically it's the way of keeping the sound from going down the intake, pretty much. It's a really, really interesting design. Of course, this was very, very old Connor model, so it's a lot of this stuff is unnamed. So I kind of have to just point and click and then hope it adds the right part I'm thinking it was going to be doing. Huh. Okay, but there we go. That's the Thunderbolt, which you guys have seen in a video a long time ago now. I have not really done any update on it, and I really think that one of my plans is I really just kind of want to go back through this and actually just wipe it clean and start from scratch, because I'm not really that happy with the Thunderbolt model. It's just hokey. Like the horn doesn't look right. I think if I tilt it to the side, the horn does not look correct at all. It's way too long towards the taper on the back end towards the stator. So that's just, I don't know, there's a whole bunch of things I want to change on it, and plus I'm not going to be using the same motor I used before. And a lot of the parts in this model are different now, basically based off of what components I can actually get to operate it. So I'm not going to be using a lot of the stuff that's on here. But give it a little bit of a cutaway, see if I can kind of get it chopped up a little right. Struggling with me a little bit here. Oh, you know what? I can just do this. About 12. There we go. So that's the cutaway of the Thunderbolt. Of course, this is not including any of the brushes or anything like that. You actually can see the slip rings down below right here. Those are actually the slip rings that I'm highlighting in blue. But the Thunderbolt is really well designed in that there's not a whole bunch that's impeding the air path going up the tube into the motor and then the stator and out the horn. It's a very, 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 very fun design. It was a lot of fun making it. But for those that are wondering what this, oh, I just made everything just disappear. But for those that were wondering, kind of what the actual rotor looked, or how I designed my rotor to look like in this, I'll go ahead and take off the stator cap, and we'll look at this really quick. So this was my design for the rotor. It's funny because I said it was a 4.5, but now that I look at it, it is a 5.6 rotor. But that's my little baby's first Thunderbolt, baby's first Thunderbolt rotor. Of course, it would be changed now, and I also, if you notice, there's no hole that's cut in the center right here for the hub, because I basically designed this to be eventually used with kind of whatever motor I wanted to, in case I wanted to make this whole thing like bigger. But I changed my mind on it. Yeah, the Thunderbolt's horn is made of multiple pieces. So I mean, because the real one, of course, was all welded together. So they. Oh, hold on. Oh, thank you, Consolidation, for subscribing. Hope you get to see a bit more of what I kind of do on this channel. Of course, you can always look through some of my past videos. You can get a look at some of the other stuff I have on here. But yeah, the Thunderbolt's horn was actually made out of multiple segments. So the reason why they most likely did that was because since the horn was made out of just sheet steel, just mild sheet steel, it's not very easy to actually mold that entire horn. If you're going to be molding that horn by, say, like a big hydraulic punch that was going to come down and basically stamp out the entire horn shape, it is way too long of a taper and way too, just generally large of a horn, that if you were trying to use some kind of compressive method of actually making this horn like they do nowadays, a lot of well, like they did for a little bit. The Eclipse is a different story. The Eclipse horns are all cast. But to make the horn like that, if you were trying to punch it, you would actually end up stretching the steel, and you actually would end up basically tearing the steel apart as it ran through the punch. So instead of doing that, they just decided to just cut several sections and kind of just like origami a horn together, which is basically what they did. And the reason why the jail bars were designed the way they were, because of course everyone associates the jail bars with being the really really early Thunderbolts, so being like the like early 50s to, I think they stopped doing jail bars around like 56 or something like that, or no, sometime around, yeah, around like late 50s they stopped doing that. But the reason why these jail bars were actually designed the way they were is that they're not actually guards. They're not there to like keep debris from getting inside the Thunderbolt. That's why they actually had the screen there when they're on the outside. The jail bars are actually there to reinforce the horn, because there is such a high concentration and volume of sound coming out of the Thunderbolt that as the siren pitches up, so it increases in speed with that blower behind it the whole time, it's basically doing a frequency sweep as the rotor sweeps up or spins up, and basically this whole horn, because it's made of different sections, would start to resonate at different points, basically causing the entire metal of the horn to essentially start vibrating at whatever its resonant frequency was, which is why they ended up reinforcing it with all those braces on the inside. And it's also why, if you look at some really, really old Thunderbolts that are still in service, or some of the ones that have been in service for a very, very long time, they almost always have a crack that's running right around right here somewhere. It's usually just past the actual support arm, but somewhere in this general area they almost all have cracks on them because of that resonant frequency basically just vibrating the hell out of them. Let me go ahead and move all this stuff kind of back. Whoa! Of course, that's Fusion kind of having a seizure here. So let's get rid of these doors, and you can get a better look at this rotator, kind of the way I had it designed. When you remake it, can you make it 4.5? Yeah, I definitely can make it 4.5. It's really not that hard to change the chopper up a little bit to make it kind of whatever tone I wanted to. If I really wanted to, I can make it single tone also. Did you know that Thunderbolt 1000 in Castle, California is a jail bar? I didn't know that. I only knew that we had there was only a couple of Thunderbolts that were in California. There used to be one like right by like Knott's Berry Farm that got removed quite a while ago now. But yeah. So I think I have enough data now to kind of get an idea of what people want to see me make. So I was going to originally do kind of a thing where I kind of just present some ideas of stuff I can make and then let the chat kind of choose. But it seems that the chat kind of has their own ideas as to what they would like to see me make. So if you guys have any other things you'd like to see that you've got ideas for, just post it in the chat. Post it in the chat, and I'll think of something else. I'll think of which one I want to do the most. Thunderbolt 1006 siren, basically a Thunderbolt 2000, but it has a generator for power. I think you're getting a little. I think you're a little confused there, Tri-Blaster. The Thunderbolt 2000 is the one that uses a generator. The Thunderbolt 2000 uses a Wisconsin 4-cylinder gas engine to run the blower, but on the other end of the blower of of that engine shaft, there is a generator on there. That generator is used to run the actual head, which it doesn't actually matter because since the Thunderbolt is using basically a Model 2 motor, it can run off DC. So, I mean, it can run off DC. It's not going to rotate off of DC, but the Thunderbolt can operate off of DC if you really wanted to. So you actually could technically make a battery backup Thunderbolt if you really, really wanted to. All you got to do is swap for a different blower motor and swap for a different rotator motor. That Thunderbolt you're talking about is actually a System 7026. I'm actually unfamiliar with that. Never heard of a 7026. I've heard of a Thunderbolt 2000, but not that. Alright, so let's go ahead and make some of this stuff uneditable so I can kind of have some space for some sirens to model. Make that read only, because I'm not going to be making that right now. Oh, this is also something else. Before I start making a siren, I thought I want to kind of show some people this, because no one got to see this, because I didn't actually release it on any of my, anything on my channel. But maybe a few people would recognize that. A Mini 2 or 2T workable? Yeah, definitely. Definitely, I could definitely work on. That'd be kind of a fun one to make. Be a little model 2T, like a little tiny one. Yeah, definitely. And the one remaining in Buena Park and the 2000 Windsor Hills. Yeah, I haven't gone to see that Thunderbolt 2000 just yet. I probably will do when I go back to California for Christmas to take a look at it. Sirens and Aircraft. Yeah, it's a Cosgrave. It's a Cosgrave slash Gamewell Codewell siren. Initially invented by C.S. Cosgrave. I believe that's his name. No, well, just a second. I actually have that description there. Yes, I'm wearing my pajamas. Yes, but a lot of the reason why I actually wanted to model this siren when I did was because I actually have the original advertisement for it. This is from 1932. This is actually the advertisement itself too. This is not like a picture of the advertisement. So that's actually a physical cutout, which is really interesting. Alright, so I think we got enough ideas in the chat to kind of go with something to work off of. I like the idea of a Model 2 or 2T, not because that's particularly interesting, but because it'd be a nice kind of warm-up of something I can make, I think, relatively quick. So, we'll go ahead and get prepared to do that. Wearing my Taco Bell shirt. Alright, so let's go ahead and do something a little interesting here. So, of course, every modeler's best friend, you gotta make sure you have one of these pair of calipers so we can go ahead and actually get some dimensions for things and kind of bring the dimensions we're using in Fusion into the real world and kind of get an idea of how big things actually are. So let's go ahead and get rid of that. I'm not going to be using the Cosgrave. Make sure I have enough space here. Basically close off a whole bunch of my documents I'm not going to use. Make that read only. Make this read only. Of course, I can always open these back up later and come back and edit them. But Fusion is a little cagey with how many items they let you work on at a time. More people in the chat. More people in the chat. I'm up to 8 people. All Thunderbolts in California are one in Crescent City, no horns songs. Yeah, the Sen and Onofre system, which they're actually going to be removing soon. So that's a chance for Aaron to go get ahead and get a hold of another one, which he actually can get a hold of a 1003 because I think there's a couple of 1003s there. Buena Park, Windsor Hills, Berkeley, Stockton, Castle, and West Covina. Make a Scream Master. Scream Master would be kind of an interesting one too. Alright, so let's go ahead and start working on something. So as I said before, to make sure you gotta have, if you're gonna be doing something like this at home, have yourself a pair of calipers so you can easily, like I said, bring that dimension into the real world. So if I set something to be about 40 millimeters in Fusion, I want to be able to open this up and actually see how big 40 millimeters is, so I can kind of get a scale of how big it's going to be. Another thing you can also have, if you don't have a pair of calipers, is honestly a gauge it. This is like, I think like $1.50. You get it at like Home Depot. It's really great. It's got all the dimensions of a whole bunch of stuff on it. Basically a more complex ruler. So if I'm going to make this model, functional, I'm probably going to need, some parts, some components to kind of base off what this is, what's going to be inside this thing to actually operate it. So go ahead and grab myself a new motor, because I always forget the dimensions of these motors. So open up my box of components. These are rotator motors for the 500s, which will be coming out relatively soon. And let's see, I'm gonna make it a Model 2. That's gonna be a really small rotor. I think the Model 2 would be a nice little warm-up, something I can kind of try to speed run through. I knew it would come up. I knew someone would ask. Mississippi Tornado Sirens and More says, can you make a 2001 SRN siren? I definitely could, but that would be a super long stream because there's a lot kind of going into it, and it is a bit complex. But yeah, good suggestion. A Super Cyrex. A Super Cyrex 50 or just a single-ended one? The Ray 2009. Wait, the songs bolts are going. Yeah, I'm pretty certain that they, because when we were there, they were in the process of decommissioning that plant. I know they don't test them anymore, as far as I know. But I think that they're eventually going to be going pretty soon because they're basically in the process of ripping that whole thing apart. I know they're allocating one half of the system to stay as a museum, but I don't know how long they're going to last. Some guy will make some money off of it. Of course, if you look on eBay right now, there's one guy that's trying to sell an SD10 from Los Angeles on eBay for about $2,000. Oh, really? I didn't know you live about an hour away. AJ, hello. Wait, you're in California, man? Why didn't you ever come to the Siren meets? I had no idea there was another Siren nerd that was in California. All right, so let's get started on making something. So I'm gonna go ahead and minimize this and minimize that. So we're gonna go ahead and pull up a okay, let's go ahead and pull up a picture of a Model 2T. For sale. Yeah, I'm not trying to buy a new one. So let's see. I know that the 2T is a bit more of an interesting one. There we go. There's a picture of that. Of course, you can't see it on the stream. It's all right, man. We're probably all going to meet up again anyway, relatively soon, back in California. All right, so I got a picture of we're going to be working on a single-tone Model 2. See if we can kind of get that thing knocked out. I'm trying to figure out about how big I want to make it. Probably going to try to stick generally with the same kind of scale as the majority of my stuff that I make. So, but man, a 2T, a Model 2 relative to a Model 7, man, that thing's going to be tiny. Okay, I might have to make it a little bit bigger than that. You might have to make it just a little bit bigger. Consolidation 1282. You live near Stockton. I vacation up in the Sacramento Delta every year, or I had been, but things got kind of busy here in South Carolina. But yeah, one of my very first sirens I actually ever heard in person was the Model 7 that's in Walnut Grove that they use for fire calls. I mean, if you're ever up more up in the Delta area, you'll probably definitely find it. So let's go ahead and start working on something. So I want to see if we can make a 2T. So I'm going to start off by, or not 2T, Model 2. Model 2. So typically what I like to start with when I make these sirens is I work on the rotor and stator kind of first, and then I basically model everything else around it. So let's go ahead and start off with the rotor. So let's see, we want to make this relatively small, 60 millimeters. Get our calipers, see about how big 60 millimeters is going to be in real life. So 60 millimeters is kind of big. It's right about right there. I mean, there's my hand. So that's going to be a little big for a rotor. And I know that if I'm trying to spin up a rotor, it's going to be that big. It's going to draw a lot of current from these little motors. And for those who are wondering, these are the kind of motors that are used in all my model sirens. So the like the 500 SHTT, the Model 7, the Model Ls, Model D, those are the kinds of motors I use. These are called a this is specifically, if you're looking up what this motor is called, it's called an RM130. No. The San Onofre T-bolts, they're still up with that, but there's plans for them. I think last time I was talking to Aaron, is that there's plans for, because they're converting about like half of the nuclear power plant into a museum, basically, of like, oh, you get to see how it works and all that kind of stuff. They're basically planning on converting about half that into a museum. So I wouldn't be surprised if they end up taking them down and putting them in the museum, basically as like an exhibit. And then probably scrap the rest of them. I don't know what they're planning. I haven't been in touch with them for a while. The first siren I ever heard was a Darley 3V8 in Colombia. Darley 3V8? Sure it's not Century? RM130 motor. just like the RM130. But yeah. AJ, stuck here in Georgia. Hey, you're not stuck there in Georgia, man. I'm in Columbia. The South has its fair share of a lot more sirens than the West Coast does. And the sirens here are actually used. Alright, so let's go ahead and make this rotor for this Model 2 40 millimeters. I'm going to start with that. I'm going to press pull this so I can make this rotor have a bit of thickness to it. It's not just a sketch. And kind of as I go through this, I'm also going to kind of explain how fusion works and kind of how it behaves and when I'm trying to model stuff. So these are real engineering principles that if you want to start doing this kind of stuff by yourself, you can kind of tap into it and you kind of learn together. So I'm going to make the thickness of this bottom portion of this rotor 2 millimeters because I want to make sure I have some kind of steady base plate for basically the whole thing to spin on. So make this whole thing about 2 millimeters thick. I'm also going to need to make the walls of this rotor. So I'm going to go ahead and come in here, make another circle, do one that's the exact same size, and then do one. How thick am I going to make these walls? Probably, if I want to make the rotor a bit heavier, if I want to have a bit of a longer wind down, because it's a Model 2 rotor that's got really big vanes in it. So it's going to have a lot of drag on it. So let's go ahead and make this rotor probably about 2 millimeters thick, so it makes it a little bit heavier. Go here, press pull, go back to our side profile, and we can take this and actually expand the top of this to basically make like a bowl. Let me look at my reference image really quickly. And that's also the secret of doing this stuff, is that when you're modeling sirens like this, make sure you have really good reference images. The more images, the better. From different angles, top-down view, taken apart, whatever you can find. Because if you don't actually own the sirens, it's very hard to just kind of free model with what you have in your head. So, because they're not too tall, actually. So make this probably about 14 millimeters. 14 millimeters seems a little small in my head. Yeah, it's going to be about that big. It's really not that big of a rotor if it's going to be spinning on that. Let's make it just a little bit bigger than that. Let's go probably 16. Okay, that looks a lot better. So we're going to join those two components together. So now we have essentially our little dish here. Not very interesting, nothing too phenomenal going on. And don't worry about this bottom portion. I know that the Model 2 rotors are hollow. You can go all the way through them. Basically, the vanes act as webbing to hold the whole thing together. So we're going to model that later. We're going to basically just cut that out. So we have our dish here. We know that's going to be, if it's a model, oh, hold on. Got to keep responding to the chat. First siren you heard was a Model 2. Which Model 2? The rate 2009. If you say you're not far from San Onofre, you're probably thinking about the one that's on. I think there's a fire station out there that has one. Mississippi tornado sirens and more. I've seen my first Thunderbolt in Laurel, Mississippi. I haven't actually gotten to hear an active Thunderbolt with with an actual 3-phase blower on it. I haven't gotten to hear those. I heard the ones that Eden has, of course, but AJ, my first siren was a 3T22 in Newberry County, South Carolina. A 6-hour round trip for 2 minutes of attack. Even forgot to ask to press test the button. Oh yeah, to press the test button. Was that 3T22 actually hooked up to an AF timer? Did it actually have a fire code ability? Consolidation 1282. Yeah, it was Darley 3V8. Its coordinates are okay. Cool. If it's on the siren map, I definitely could pull that up and look at it later. Mississippi tornado sirens and more. The first siren I heard is a 2001 SRN, which is next to my house. Yeah, there's one not too far from our house too. There's one that's what's that street, babe? Is that like a what's that bridge that goes over the Congaree? That's that siren's right there by Ed Venture. What's that street
it's
called?
Not Juve, but it's the other one.
Is it Taylor?
Taylor sounds right.
I think it's the Taylor Street Bridge. There's a 2001 right there. I've seen it rotate, but I think I've never actually heard it. AJ, my main issue is very unreliable testing. That's too far from my home, and I still have a little while before I get my learner's license. I understand that, man. I was there. Thankfully, Los Angeles is so condensed that you can honestly take a bus. At least in LA, you can take a bus or you can ride a bike. So it's not like there was 2 sirens that weren't far from my house that are part of the legacy system. There was a SD10 which I ended up climbing, and then there was a 500 which I ended up climbing as well. That's the first one I ever climbed. The Raid 2009, the first siren I ever seen was a Wayland 2806 about 7 years ago, part of the song system. Yeah, rest in peace, song system. That's all gone now. Me and Aaron actually tried getting one of the 2810s when they were actually taking them down, but then we never actually heard anything from the guy that was taking them down. Okay, so Model 2's 5-port. They got pretty wide ports. So we're going to head and go to here. We're going to go to construct. We're going to do tangent plane. So the tangent plane allows us to basically make a sketch. And the way that Fusion works is that basically almost everything that you're making is based off of sketches. So they are 2-dimensional drawings that basically give dimension. So tangent plane allows us to draw one of those sketches on something that's round that you normally can't. It's something that's 3-dimensional that you can't normally put a 2-dimensional image on. So we're going to do tangent plane. We're going to select this face right here, and this allows us to open up our construction plane and allows us to actually draw something out. So we go ahead and make these ports. Now I know that the Model 2 has some pretty freaking big ports, so let's go here and do create sketch. We're going to sketch on that construction plane that we just made. And thankfully, Fusion makes it a little easy because they give us these handy-dandy little grid lines. And depending on what kind of dimension that you're using, these grid lines, based off of where I'm zoomed in now, is based at about half a millimeter per little cube. So if I take this little line right here, for example, and I go and I do that, oh, that's actually 1 millimeter. Never mind then. I guess I'm zoomed in a little too far out. But it gives you these handy dandy little grid lines so you can make your stuff. It's not as hard to actually model it. You don't have to go off of like fixed dimensions that you have to measure out. So we're going to go here. I'm going to do a quick little thing to kind of give me a general dimension of about how big these ports are for the Model 2. So I made this. How long did I make that? I don't realize how long I just made that. I kind of just pulled it over there. So I made that 7mm. So each port is going to be about 14mm across. Which I know seems really, really big. Seems really, really big in hindsight. Okay, so we're gonna go ahead and ooh, I don't want to cut that. I don't want to cut that tall. I don't want to cut that tall up there. So we're gonna go ahead and come down here. Measure about, that's about 1.5 millimeters down from the top. I'm still not entirely pleased with that. Let's go back a little bit. I'll put that line somewhere else. I'm gonna put that line right up there, so there's only about 0.5 millimeter space on the very top, and we want to conserve that 2mm. With it, keep in mind that there's 2mm coming up from that bottom right there. So say if I went over here and I went to inspect, I did a section analysis really quick, and I cut this in half. Of course it cut in half on the other side, that's fantastic. But if I look on this, I could see my sketch in the background right here, and you have to keep in mind that this is 2mm, that there's a 2mm rise from the true bottom of the part that I'm modeling up to the top, because I'm trying to make this thing have a bit more weight to it. So keep it in mind when you're modeling stuff like that. You don't want to end up drawing your sketch too far down and you end up cutting into it. So I'm going to cancel that and go back to where I was. The easy way you can do that is honestly just take a line, go from the very, very bottom of what you were sketching on, and go up 2mm, because then that gives you kind of a base to know where that line starts. So I can go back over here, sketch that out over there, one more over there, and then just connect these to basically make our port. So now I have my port sketched out. So this is just one port. It does look a little big. I might have to kind of shrink this down a little bit. It might have to be about 12mm port, dimensional, like width-wise. It might be a little too big. I've got a lot going on here. I got to kind of read the chat at the same time. It's kind of overwhelming. I got the chat pulled up on my phone so I can look at it too. Wheeling 2806. Okay, I saw that. Sirens and aircraft. There's a Thunderbolt 2000 where I live. That's cool. That's cool. I'd love to see pictures of that. I don't know if it's on your channel or not. I'll have to definitely check you out a little bit later. Triblaster. I own a real siren. I own 2 real Bosai Musen horns. I have no controller though, and MS390 120 volt. How did you get 2 Bosai Musen horns? Considering it's a Japanese siren. How'd you get Bosai Musen horns? Banjo B 2005. I'm so used to going off of siren nomenclature. Banjo B 2005. The first siren I ever heard was in South Milwaukee, P50, right there by the fire department. I was probably 4 years old. But that thing probably was screaming too. AJ, I do have the TY bolt nearby now though. I apologize if I'm kind of fudging the chat. The Ray 2009, I have a 2000. There's a 2000 in Phoenix that's electric converted. Yeah, I know they got a couple. They got a couple in Phoenix that have been converted over. There's one that what's his name? He's an old YouTuber now. That I think he originally got a 2000. I think it was a jail bar too that he converted to be gas again. I think it was in Orange County somewhere. Yeah, I know there's a 2000 that's in Windsor Hills. I think it's the one you might be thinking of still. My first siren was the Cosgrave siren. AJ. Yes, but it had been disabled. The upper damper had lost pull from the return spring somehow, so they disabled the RC6 and wired to the fire. Yeah, that makes sense. That makes sense. Very common because the damper return is on just a spring for those solenoids. The 2001 by your place spins at 11 RPM. Interesting. AJ, this is station 11, St. Philip's Road. If you didn't know. Okay, that makes more sense. Ray 2009, it was SPO1 to be exact, the Whelan. Consolidation 1282, yes, it was also on the California statewide siren map as well. Cool. Yeah, I haven't, I mean, I basically have, it's funny because every time I go somewhere and I pull up Google Maps, it's fun because it automatically has an overlay so I can see all of the sirens in California and I can see all the sirens in South Carolina too because I have both the maps saved. So every time I'm driving down the highway, I'm like, oh, there's one coming up. It's kind of fun. Justin Lim, hello. Nice to meet you, Justin. Kid Crazer 14 and warning sirens of upstate New York. I'm going to make a supercharged Vixen horns for next year. That'll be interesting. Sirens and aircraft. What's your favorite siren? I definitely have a favorite. I have a preference. I mean, the very first siren I ever went to actually 3D print. Hold on, I got something on my face. It's kind of annoying me. The very first siren I ever actually 3D printed, and the one that I really wanted ever since I was a kid, was actually a Model D. That was it. It was just a Model D. All right, so let's go ahead and before I continue on, I'm going to cut this really quick and see kind of how it looks. I'm going to do a quick little pattern to see if I can even actually fit a port that size on this rotor because it's a little big of a port. Triblaster offline from Korea. Oh, you had to have gone through some like weird import site in order to get it. The Ray 2009, the Model 2 was in Orange County. The Model 2 heard a long time ago. Justin Lim, I know a Wayland 2803 that's in Senator Wash Drive in the Imperial Dam, or by the Imperial Dam in California. I'm not actually sure where the Imperial Dam is. I basically, like, again, I stayed generally around the Los Angeles area, and then some stuff up in, like, Sacramento, but interesting. Yeah, there's also a Model J and a Model D by the Devil's Gate Dam in Pasadena, which is not far from JPL. But yeah, my favorite siren was actually just a Model D. There was a Model D that was on a little kind of like fire shack. It wasn't manned, of course. There was no one that actually was in there. Basically, it was just like a fire supply shack that was at this resort I vacationed at every single year. And I had always seen it since I was a kid, and I knew what it was, but I never really had much of an opportunity to actually get up to it. It was disconnected. It was used basically just to warn of like flooding. Wow, that is a really, really spaced out. That is a really, really spaced out port. Okay, we're gonna have to make that a little smaller. That's a little too big. But yeah, I wanted that siren since I was a kid. It was hooked up to like a Gamewell coded pole station. Basically, it was to warn. It basically was just to warn this like little island because there's a little island resort in like Isleton, California. If you want to look it up, it's called Vieira's Resort. Vieira's Resort. Vieira's Resort. Not far from Walnut Grove, where that Model 7 is, and that Eric fire siren, which is on a grain silo there. But that Model 5. That Model D was up there for such a long time, and I always wanted it. I always asked the guy that actually owned the resort if I could have it, but he didn't know if it was still hooked up. He didn't know if it was still going to work. And he basically, I mean, it was. I had, of course, had known because I had been inside of that little fire shack multiple times because I wanted to look at the wiring going to it. And to be honest, it wasn't until I was like maybe like 18 or like 19 that like I was vacationing there again, and I had gone inside the fire shack and I saw that it was disconnected. Like it was completely disconnected. There was like the wiring that went to it was like long gone. So it was literally just sitting up there with no wiring going to it. The pole station is not connected either, to be honest. And it clearly hadn't been connected in a very, very long time. So I just took the damn thing. Like I quite honestly, I just took it. It was disconnected. I knew it wasn't going to be missed. When I got up there, I actually climbed on the roof to go get it. And it was like I said, it was disconnected. It very clearly hadn't had any love given to it for a long time. It was really badly rusted too. That motor case was falling apart. So I restored it, and that model. That very same Model D is the Model D that's on my channel. It's the red one. That's the Federal Electric Model D. It's the Dimpleback. What's this idea for your siren? I'm missing a lot of information. So yeah, I'm going to be working. This is actually going to be a Model 2. This is going to be a miniature Model 2, because I had a couple people in the chat that were requesting doing something like this. And I think a Model 2 is kind of a great little starter to kind of dip my feet in the water a little bit. Okay, that's a much better looking port spacing. It looks a lot better. So five port, of course, it's just a standard Model 2. So now we have to add some vanes to it, so I don't want to actually do that. Let's get away from that. So, and of course this Model 2 is going to be, I'm going to make another sketch right here really quick so I can clean this up a little bit. Okay, I'm just going to finish that sketch right now. So then I have another ring basically around here so that when I eventually need to press pull this stuff later, I can actually select these as separate entities and get rid of them. Okay, so now let's go back and do another section analysis so I can kind of see where I'm going with this. Cut this in half. We're going to keep that section analysis so I can go back in there and look at it basically as a cutaway. And then we're going to start making a port. So, go ahead, or not a port, a vane specifically, excuse me. We're going to select an axis we want to rotate around, so we're going to select that one. And we're looking at it from the front. So let's go ahead and get rid of this analysis for a second. Does that port line up where I'm going to want it? Oh, sweet. Okay, never mind. That port lines up fine. So I actually can get rid of that and give our analysis to the hens. I'll get rid of this. Now, I know that the Model 2, the Model 2's vanes are kind of thick. They make the vanes really thick. Again, because it's basically supporting the weight of the whole rotor. So I'm going to make the center hub of this thing a little bit bigger than the real Model 2 is, because this is just a constraint of the scale I'm kind of working with. So we're going to make the center hub about 6 millimeters. 6 millimeters around, which gives me plenty of space to fit this shaft, because this motor shaft on the motors I use is 2 millimeters. So we're going to go ahead and do that. Set that sketch, go here, press pull. So we can take this sketch into a three-dimensional object. Bring it up a little bit. Let's do that section analysis again. I want to see how tall I'm making this thing. About right there. About right there looks pretty good. Oh, my back. My back is thrashed, man. I've been working like crazy this past week, so I've just been slugging through it. Okay, so we're going to join those two together, so now I have a hub. Get rid of that analysis again. And then this is all, of course, going to look very rudimentary because of basically what I'm doing. But actually, that analysis might come in handy here a little bit. So I'm going to go here, go to construction, do an offset plane, so I can do construction right off of this little face right here. And I should be able to come in here and do a sketch. Whoa! Whoa, why is it bisecting? Okay, that's not what I wanted to do. Let me actually go through here and make a line instead. Oh, go away. Oh, Fusion is fighting with me now. Sometimes it's very annoying what Fusion decides to make invisible and what it decides to keep together. So let's go back in here and how am I going to do this? Let's go get rid of this analysis, go back up from our top view so I can see that we want to draw a vane from this center hub out to the edge of this rotor. So we're going to create a sketch. Just get a line, go from this to this. That gives us a general basis to kind of go off of. And say we want to make this vane, I don't know, what about like 2 millimeters thick? So we can go over 1 millimeter, go over another millimeter on the other side, and then basically just connect the dots. essentially, is just connect these lines together so that it actually makes the profile of the vein. Whoa, go away. Okay, so now we're going to make the profile of this vein. We're going to come over here, press pull all these components. And if it's going to play nicely, which Fusion sometimes doesn't, it can be a bit of a pain sometimes, we're going to actually be able to draw this vein. And then just pull it up like that. That connects, as you can see, quite cleanly. Go up a little bit more. I'm going to, of course, shave down that edge so it comes out to be nice and clean. But that is one vein. Now, I don't want to join these two together just yet. I want to make this its own independent body. That's what I just selected right here. So operation, after you create a sketch that's referenced by something else. So in this case, this drawing of this vein that I just made right now is referenced to this rotor. It's referenced to this circle down below. So if you are drawing on it, once you make that sketch a three-dimensional object, you can either select it to join to the sketch that you based it off of, like the center of the rotor. You can either cut it so that it would actually cut out that section that I was making, basically what I was drawing. You can make it intersect, which I don't really ever use that much, or you can make it its own new body. So this is now its own independent thing that is not in any way connected to that bottom rotor, and that I can also base other sketches off of. So I'm going to make this its own new body right now, so I can kind of work with just this. I'm going to fillet this edge. That's not what I want to do. I don't want to fillet. I want to chamfer this edge. I want to chamfer this. So you just right-click, select chamfer, and this will give it a nice cut profile, similar to the way that the veins are shaped in a 2. But as you can tell, that profile is way too sharp, way too inclined for it to look accurate to a Model 2. So what we're going to do is you can also go to type, so you can actually select how it's chamfered. And we're going to go to distance and angle, so I can change how far along this entire piece goes in terms of how far it's cut away, but I can also change the angle at which it's cut. So I can actually get this to line up pretty reasonably close to this center hub right there. So I have it set at 20 degrees. Let's go about like 22. Let's see what 22 does. So 22 lines it up pretty freaking close, man. And I think I'm going to call that good right there, because the Model 2 rotor, look at my reference images again. Just looking at some reference images so I can kind of get an idea of what's going on. Oh, someone's selling a Federal Model AX. That's kind of cool. Typically, I see a lot of sirens on eBay get sold for way too much, which is unfortunate. So can't Pendleton change the controllers on the songs, Waylands? I'm not sure. I don't know actually. The Ray 2009, I was on CP and saw them. Nope, the original controllers are still connected. Kid Crazer 14 of Warning Sirens of New York. I really want to make a mini Thunderbolt. I have a 3D printer, but I don't have the time. That's usually how it goes, man. It's like you can take the printer will do its own job, but it's making the model. It's usually is the hardest thing. I understand that. A lot of my sirens, like, I just don't get around to actually making them because they take so long to make. But thankfully, I've gotten a lot better at actually doing that. Justin Lin, I was in California for vacation once. I found the Seal Beach DSA and modulators. Yeah, those are pretty common. They're going to be putting sirens in Beverly Hills now too. I think they're proposing to do modulators. I think they're doing it for like wildfires. I'm not entirely sure. I haven't been in Beverly Hills in a long time now. But they were talking about doing that a couple of years ago, but they're finally getting around to doing it, I think. The Ray 2009, nice. Justin Lin, I think there's 2 to 3 Super Cyrexes still remaining in California, correct? I'm not sure about that. I haven't looked on the map in a little bit. I don't think they're there anymore, unless they're probably like way up north for all I know. Consolidation 1282. There are 3, 2 at the dam and 1 in Sacramento. Yeah, that's what I thought. I thought they were further up north. Aren't they looking for sirens? I don't know. I guess you guys are kind of chatting amongst yourselves right now. So let's go ahead and get back to this. So I've got this profile for this vein, so I'm going to save that. It looks pretty good where it's kind of at right now. So we're going to go to create and then use pattern. This is my little cheat here, because rather than actually going through and modeling the rest of all these veins, Fusion makes it really easy to just come in here. Let me get a drink really quick. Get something to drink. Yeah, I spilled some water on my shirt. But Fusion, this is the reason why I like Fusion. If any of you guys are modeling your own sirens or kind of doing your own stuff and want to start modeling your own sirens, I would highly recommend Fusion. Fusion 360 is a lot better than what a lot of other guys are using. Like I know that BSP, for example, uses like Tinkercad, I think is what he uses. That Tinkercad is a very basic program for kind of modeling stuff, and you're kind of limited by using just shapes. You really can't add a lot of dimension to things, and it makes it a lot harder for making really intricate models, such as the Chrysler or something else. It's just not, in my opinion, just not a very good program for doing that kind of stuff, for designing really complex things. But Fusion 360 is available for hobbyists. You can go online. You can download Fusion 360, and you can apply for just a hobby license. And you're limited to about 10 models, but I have more than that. By just basically making certain models invisible, so you can't actually work on them. But you can have 10 active models you can continuously work on. So like I have a whole bunch of them pulled up. You can see right up here on the model count. I have 6 out of 10 models that I can make right now, pretty much. But Fusion 360 is free. It's a great like semi-professional program for doing this kind of stuff. It's got a lot of really helpful tools. So, and like I said, one of them is pattern. So I can actually just select and make this a circular pattern. And I can come here and select bodies, which is why I left it as a body and didn't actually make it a part of the rotor. I can select that body, select an axis I want to rotate that whole thing around, like the hub. Just click it. There's 3. There's 4, there's 5. So now I have 5 of the veins right there ready to go. Click that, finish it, and that drops in the veins right there. So now all the veins are there, about where I want them. Those veins are really freaking thick, man. I didn't think it was going to be that thick. But again, I kind of wanted to make them just a little bit thicker than I usually do, because I do want the Model 2 to have a bit of a better coast than they typically do. Than my other model sirens typically do. So, what else are we going to have to do here? So, I have to get rid of this bottom portion because it is a Model 2, and the Model 2 has an open bottom on the rotor. So I have thankfully left this as an active sketch so that I can actually come back in here, select this. Excuse me. I didn't expect that to come fighting out of me, didn't I? Hold on. Let's go back here, make this another sketch. I gotta sketch another circle really quick because I think it disappeared. Then come back in here, sketch this. This is 38 millimeters? Yes, 38 millimeters. So now I can take this, sketch this, press pull. I can select all of these individual little pieces that it's kind of just like an artifact from when I cut it. Go back in here, scroll down. Operation. Fusion already knows generally kind of what I want to do with it, so the operation it's selected is cut. And if I was on goofy mode, I can actually just make it join, and it makes the rotor like insanely long. But we're going to be using cut for this, so it'll cut out the bottom of this rotor, and it'll leave it just like that. So now I have the cut Model 2 rotor, and it just basically cut out the bottom 2 millimeters of this rotor. So that whole bottom is now gone. This leaves a little bit of a hub that I can connect to. Now, another thing I have to kind of consider here is that this is going to be printed on an MSLA printer. Well, actually, no. I can probably print this on Catherine. You're making a 3D printed miniature Model 2. Reminds me of the time me and one of my friends made both 3D printed miniature 4.6 and 5.6 Model 2. Yeah, if I want to make a 2T, I mean, I really kind of could, but I don't know. I think just a Model 2 by itself is also just an interesting siren. And yes, I'm aware that I've been sticking around federal stuff quite a bit. Believe me, I am quite conscious of that. I don't know, in terms of companies, I think federal is just one of my favorite. So we're going to sketch another circle because now I have to add this little ring that kind of goes around the top of the rotor. So we're going to start from there. 38 millimeters, and then I need to cut a little bit of a hole. That looks about right to about where a Model 2's rotor is. So let's do this. And now I can add that back. So I'm going to add those 2 millimeters back to it. So I'm going to go -2. And that'll add that dimension back to it. So now the bottom of the rotor is connected to this. And I can click join because I'm going to save that. Or I can actually leave this as a new body. Do another little cheat here. Leave this as a new body and don't actually connect these two components together. Leave it as a new body. Go over here. Select this part. Translate. So I can now move this part. Check create copy. Go over here. Move this entire ring up. Ooh, that looks ugly. Maybe not. maybe I can't cheat on this one. Alright, I guess I'm going to have to go through and actually make that myself. That's kind of annoying. So I might as well just combine those two then. You can if you want to make this its own thing, you can actually go to the combine tool after you've made a certain part of the rotor its own individual body, and then just click combine. It'll add the two together. So there we go. So now I want to go and make this just a little, whoa, let's not do that. Make this a little deeper. Bring that down a little bit. That's a millimeter down. This is where my whole worldview falls apart. I'm going to cancel that. We're actually just going to make this on this top ring. Make a new ring. So now, go over here. Where did I make that size? Where did I make that size? What size is that ring in the bottom? That right there. Okay, so we're going to go here. And I should be able to basically just cut this. That's 1 millimeter down. Instead of cutting that, I want to actually join this. And I think I didn't actually make that a millimeter. I didn't make this little profile right here a millimeter, this little edge right here. This lip in between the top of the port and the top of the ring. I didn't make that a millimeter. I think it's about a ½ mil. So we're going to go ahead and make that about a ½ millimeter. Okay, that looks far, far better now. We're going to join those two together. So there's basically a Model 2 rotor kind of assembled. So it's just the rotor itself, of course. That's nothing special going on. So I typically like to leave my hubs I kind of like to leave my hubs unbroached. I'm not going to actually put a hole through it. This thing right here, this is another option that Fusion has, which is the hole option. When you're actually trying to cut a hole, I swear to God, I cannot stress this enough. Never use that. If you're modeling something and you're trying to use just the hole tool, it makes these like goofy little holes all over the place. If you want to chamfer something and make it like the hole is for like when you're putting threads into stuff. I never ever use it. Never ever use it. If you want to make a hole, go in here, click sketch, model a circle, make the hole the right dimension, press pull, and make the hole that way. Trust me, it'll save you a lot of headache in the long term if you're modeling sirens yourself. I'm going to get rid of all that. Okay, so now we're going to go on to more of the interesting stuff. So now we're going to get on to trying to make the stator profile, which is a bit more difficult than doing something like the rotor. The rotors, once you've done it once, and you've just kind of practiced making rotors, they're really not that hard to model. But stuff like this kind of is. So now we're going to make the stator, because the stator on a Model 2 has a bit of a weird profile, where it is one continuous cast piece and then tapers at the top where it's got that center bearing hub of the bearing mount. So we're going to go down here, go to the bottom of this sketch. We're going to base it off of this. And now we have to kind of figure out about how much of a tolerance we want to have between the rotor and between the stator. How much space are we going to have in between the two of them? Because of course it's a siren, we can't have them touching together. So typically what I like to do is I usually will give myself a bit of a leeway. So if I know that the rotor's dimension is about 40 millimeters in diameter, I will sometimes go about 40, like 40.5. Give myself about half a millimeter of space between the two. And that is typically, if I'm FDM printing this thing, which is the filament-based printer. I mean, an easy way to think of to remember the two different types of printing is FDM. Just remember the F. Just think of the F as filament. FDM stands for fused deposition modeling. MSLA stands for masked stereolithography. So just remember FDM, filament, MSLA, masked, like screened. So usually the MSLA printers have a bit more accuracy when you're making dimensions on things. So I'm going to make this about 40.5, which gives us about a half a millimeter of space between the rotor and stator. Looking at it now, that looks like it's going to be pretty tight, especially knowing that this rotor is going to be kind of ripping inside of this thing, this little motor. So we're going to actually make it about 41. Let's make it about 41 millimeters, or 41 millimeters in diameter away from this stator, or this rotor. So basically we're going to be having essentially 1 millimeter of space in between the rotor and the stator. Now it's kind of figuring out about how thick we want to actually make this stator. So let's make the stator, if this is 41, I want to make the stator probably a little bit thicker, so I'm going to do this about 44, so that means the stator is going to be 3 millimeters thick. So we're going to come up. Oh, we're on the bottom. I forgot about that. I'm going to flip it back around, right side frontwise now, and we have now basically masked the rotor. So here's a little cutaway of what that looks like. So here's the gap that we were talking about. That's the tolerance. And we can now see basically how thick our stator is. I typically also make my stuff a lot thicker because I know that my models are going to be actually used by people. And especially if you got a little motor spinning this little plastic piece around like at a crazy speed, you don't want the whole thing flying apart. So I typically make things a little bit more beefy than they have to be. That makes them less accurate model-wise, but it's kind of a give and take when it comes to engineering something. So we're going to go off with just that kind of thickness now. And how far are we off from this bottom? So let me measure really quickly. I'm going to measure from that to that. That's about 2 millimeters away from that. Okay, so 2 millimeters. So we're going to go back to one side. We're going to pick a side and kind of stick with that one. We're going to stick with just the front side. So I know we know we're 2 millimeters up, so let's go ahead and do another construction plane. We're going to do another tangent plane like I talked about before, which allows us to do a two-dimensional sketch on a three-dimensional surface. Do that. Specifically a round three-dimensional surface. And then we're going to do a sketch now. We're going to create a sketch. We make one line. We now know our dimension from this bottom point is 2 millimeters. So we're going to come over here, go up 2, not 2.5, 2. We're going to do 2 millimeters right there. And I forgot how big I made the ports. I think they're about like, what is it, 14? 14 millimeters? I made about 12, didn't I? I made about 12. So we're going to do 6 millimeters. 6 millimeters that way. And 6 millimeters this way. So then that gives us a general port shape here. And let's cut it up about like right here somewhere. Thankfully, yeah, okay, does Fusion align with that? No, it didn't. Okay, now we can cut this out and see where we end up. I'm going to also make this rotor invisible Let me go ahead and... Oh, it left the hub. That's cool. So I also want to go in here and rename that eventually so that I keep this stuff kind of together. So we're going to cut that out and see where our rotor ends up. So we're going to rotate this entire rotor around. Where is my axis? Where is my axis? Hold on, let me just reselect that again. We're going to rotate this around this axis. And we can see these ports are going to line up. That looks pretty good. So there is a very, very basic Model 2. Put that back. That's well. Now we're at the point now where if you wanted to make this a Thunderbolt, you would stop. You would stop here with cutting the ports on the stator, and you basically would just leave this like this, and then model the rest of it around to make the actual stator cap. But we're not doing that, so we're going to continue on now. I also wanted to also note that I did leave this little gap right here in between, so the stator port doesn't go all the way up and cut into this. I could make it that way if I wanted to. But we're going to leave this little gap here because, of course, the Model 2 has that little intake cone. So we want to be able to make sure that there's a lip that intake cone can kind of grab onto. So we're going to leave this the way that it is right now. And now I can select, again using my little cheat tool here, we're going to go to Pattern, again, select a circular pattern, select features. So this is looking at specifically like little interesting or intrinsic features of whatever model you're making. And we're going to select just that little stator port. So this little port that's cut out right here. And now we're going to select this axis because we know which one it is. This is a 5 port, so we're going to go to 5. And there's our stator now. There is a very basic stator, I should say. So of course everything's all blocked off. Let me also, while I'm here, combine this into one thing so it's not two separate bodies. And we're going to also rename this now. Go into our naming and name it rotor. Go to here. We're going to rename this as well. We're going to rename this stator. Now, on my very early models, when I was doing stuff like this, I was a complete and utter, heathen with not labeling anything. So, on the Thunderbolt, for example, nothing is labeled. Nothing over here is labeled. So you basically have to highlight a part and then see kind of where it lines up over here to guess which part it is and then remove it, which is really annoying. I have graduated. I'm no longer doing that kind of stuff now. So everything I do, I label, so it makes it very, very easy to keep track of where I am in the model. Let me go ahead and read a bit more of the chat and see what you guys are still talking about. I'm glad to see we still have 8 people in the chat. I really appreciate you guys kind of stepping here and joining. Again, I know I did start a little bit later than I thought I was going to. I originally selected 7, but 7 is really, really early, and I'm tired and have a life. So. Okay, so let's read a bit more of the chat and see kind of what you guys are talking about. I'm going to leave this kind of in a nice presentation. Actually, you know what? Let me pull up a different model so I can actually have it just kind of pulled up and you guys can look at it while I'm doing this, so you guys are not just staring at just a frozen kind of model. Just giving you guys some kind of eye candy here. So I'm going to pull up the Chrysler so you guys can actually see the Chrysler. I did do a video, kind of a cutaway of the Chrysler a while ago. But let's go over here. Oh, of course, I got 140 something bodies that I did not label. I am such a moron. Okay. That. I swear I'm going to read some chat. I just want to go ahead and make this all kind of together. Also, give me some feedback, guys. I'm kind of curious as to if you guys are actually finding this interesting or if I'm just taking too long to kind of get through stuff, or I don't know. I like having feedback so I can know what I'm doing right and what I'm doing wrong. Again, this is the first time I've ever streamed, so that is unique in its own right. What is that? I don't want that in there. What is this? Man, I don't even remember half the stuff I even modeled. There's a lot of stuff on this Chrysler that I've completely forgotten about. Oh yeah, this was the sound module that I had designed to actually make noise for the Chrysler, so that the Chrysler would actually make an idling noise. Of course, this is all not in the model anymore, but actually that can stay there. Whatever, we'll leave that there. But for those who were wondering what the inside of the Chrysler looks like, there it is. There's a cutaway of the Chrysler. Alright, so let me go ahead and read some chat, and you guys can kind of get a peek at that and get an idea of what's going on with that. Justin Lim, yeah, Thunderbolts in my area were replaced with 2001s and placed modulators. Ray 2009, I barely have T-bolts in my area. Closest ones are in Palm Springs. AJ says I used Blender and it was very tedious to model rotors with evenly spaced ports. Yeah, I've tried using Blender before and it's not worth it. It's just so much of a hassle to try to do anything with it. I tried using Blender like very, very early on when I started modeling sirens because I actually had it through my college, and then I couldn't get a hold of it. It was just so difficult to work with, so I ended up just dropping it. I found that Fusion is by far like one of the easiest for people that are just starting out to kind of use. And it also has room to kind of grow. So the more you kind of like learn Fusion, you can make some pretty complex models with Fusion if you just get practice with it. Mississippi tornado sirens and more. We should put a sign on Thunderbolts that say "Don't replace." Yeah, we probably should. They're a really fascinating part of American history that is sadly just thrown to the wayside quite frequently. Kid Crazer 1 and Morning Sirens of Upstate New York. If you know my channel very well, you know that there is one Thunderbolt in my country, and it's active. Or your county, excuse me. That's cool. Justin Lim is a Chrysler display in March Air Reserve Base. Justin Lim, is that which generation is it? Is it the first generation with the weird like wraparound plenum with like the 6-cylinder engine, or is it one of the later versions like what's up here on the display? Triblaster. There's a Chrysler on top of the Miami High School in Florida that's Civil Defense Yellow. AJ, oh wow, I had no idea that Florida had Chryslers. Triblaster, it's cool seeing you make your sirens. I appreciate that, buddy. I like the detailed process of explaining what you're doing with the model, how you are making that change, and why you're making that change to the model. Yeah, I mean, I figured it's more interesting to not necessarily just like just make a model. Like it's a bit more informative to sit here and kind of like explain like how it's done because I mean information's free. Like I like people to also try to make their models and see kind of what they do with them because it'd be really cool to see what the rest of the community can make. You know. Like, we have the abilities. I mean, 3D printers are getting cheaper and cheaper by the day. And certainly, you can find some really rudimentary CAD programs. It's not that hard. I mean, it's like learning how to use, it's like learning how to use Microsoft Word, you know? Like, maybe 20 years ago, knowing how to use Microsoft Word was like a skill that only certain people had, because they were so used to using typewriters and using, or teletype machines. Or literally writing out everything. Whereas now, or another example could be like Excel, where like Excel is just like some other innocuous I've got no idea what the hell is going on in Excel, or even like writing code. Like that's just I did a little bit of code writing in high school and college, but that was basically about it, and it's a skill that I just never really developed. Whereas something like Fusion, or any kind of CAD program really, is I think going to be one of the bigger things that's going to be more common in schools come leading more into the future, because it's a very, very powerful program. in that it allows people that have an engineering mindset to kind of go through and actually create things that they can physically hold and physically model that they can bring into the real world. It allows like a complete huge range of engineering possibilities that I would love to see, especially if you're a STEM lord. There's a lot of STEM students that I know that probably end up following me because of high school and college. Hi guys, sirens and aviation and more. How you doing? How you doing? Glad to see you in here. Yeah, Blender was very intimidating at first. Yeah, yeah, Blender was, like I said, I took like 5 minutes to like try to learn it, and I was like, I'm not dealing with this, man. I'm not dealing with it. It's really cool for simulations, but I'm like, man, it got a little crazy. I know that Eden uses Blender, I think. He uses it for some of his renders he pulls up. I don't know. Hello. It was red. Made in May 2001. That's cool. AJ, also, is your older Model D, are your older models like the Model D going to be available again in the future, or are they replaced by current line of products? Um, I've toyed with the idea. I actually have updated the Model D design. If I actually show you, if you've seen videos of like of the old Model D, which I think is on my channel and it's on a couple other people's channels. The old Model D, again, it was my first model I ever actually made. It was a little funky. It had a little bit of quirks to it, but I did a couple things that kind of changed it up a little bit. Like I added the actual little ring on the front right here. I added the little detail around the back reflector, and yeah, so I changed it a little bit, and I would hope to actually make the Model D actually have a weighted rotor on it, like I'm planning on doing for my sirens coming in the future, to basically have them have rotor weights in them to make them wind down a little bit longer. So I probably would bring it back after I kind of play around with it a little bit, just to kind of more refine it and get it to looking a lot better than kind of where it's currently at. Um, but yeah, definitely would probably introduce it again in the future. Actually, I even have a Model A over there. But the reason why I've kind of been doing it in little chunks of like what products I'm actually selling is because, to be honest, I'm like, man, I don't have the time anymore. Like I have a full-time job, and leaving the printer to just do its little all night and all day for the most part is about as much work as I can kind of offload on the printers to do. And but then as soon as the printer's done, after say like a 6 hour print, if I leave the print to go for 6 hours when I wake up in the morning, I have to leave for work in 2 hours, and then by the time I come, so then I'm at work and the printer stops halfway through. So that's like a whole chunk of time before when the print has stopped, and when I finally get home, that is just not doing anything because there's no one here to manage it. It would be really easy it'd be a bit easier if I had two printers, but I've kind of found that like the maximum amount of stuff I can kind of sell is about 3 items, which really sucks. Unless I decided to like make a huge, like big bulk of items first. Excuse me. If I was to make like a huge, like big chunk of items first, and then basically just have them like stocked at my house, and then just throw them all up on the site, and then just sell them all at once, and then just have people come and get them. But I'm human, and I'm human. I have ADHD, so I'm really like distracted by things I really want to work on. So like, it's really frustrating when the printer has taken up time making parts for sirens I'm selling, when I really want to get in there and have it print out this part for something I'm prototyping, because I really want to see if it works or not. So it's kind of like a give and take. It's changed a little bit because I have two printers now. I've got the MSLA printer and the FDM one. But the MSLA printer is really, really finicky. It's kind of a pain to get it to work the way I want it to, because it's resin, it's a liquid, so it's really, really flexible. When it's getting pulled off the print bed, it's really, really annoying. You're doing great. But I'm doing great too. Sirens and Aviation and more. My voice is getting a little hoarse because I've been talking consistently this entire time, but I like to talk. Uh, Kid Crazer 14 and Warning Sirens of Upstate New York. That is a long name. Um, I have Blender. No wonder I haven't been able to do anything yet. Yeah, the Model D is my favorite, so I just had to ask. Yeah, the Model D is my favorite siren of all time. I know it's one of the lesser ones. It's not a Thunderbolt. It's not like a P50 or any of the ACA ones. But yeah, it's a simple little Model D. Model D has always been my favorite. I have become very, very, very familiar with like every little weird quirk about Model Ds. The fact that even though when you look at a Model D and you see it on eBay or something like that, yeah, it's a Model D, but there's actually like three generations of Model Ds. There's the really early Federal Electric ones that, or which are known. I call them this myself. I call them dimplebacks because the Federal Electric Model Ds were the ones that actually had the 1/3 horsepower motor in them. They had the biggest motor that any of the successive Model Ds had. They had a really really big motor in them. Um, they also had the cast projector on them. They were actually made of solid metal, not just like spun steel like the later ones were. And then there was the 50s model, which was a bit cheaper, that had the smaller motor in it. It had a flat back on the back of it, and then the rotor was a bit lighter too. And then of course they had the very final version of the Model Ds, which were like 60s into like the 70s, which had the aluminum base, the aluminum base, and they had really really cheap motors in them. They had a lot of problems with those motors in those Model Ds. There's a common issue with those Model Ds that the bearings go bad in them really really bad. Sirens and Aviation. I have something on my iPad called Shaper 3D. Though I'm not used to it, Ella, but I'm getting there. That's good. Just practice with what you have. Um, I You want to see the very very first model I made with Fusion, and see just how embarrassing it is. The very very first model I made with Fusion is right here. Is this the very first? Yeah, I think this is the very first one I ever made. This is a very, very, very rudimentary little project thing I was trying to make. But yeah, this was my this was my very first Fusion model. Whoa, that is not what I wanted you to do. But yeah, that's it. That was my first Fusion model. It had round ports because that was the only way I knew how to make them, was just to basically make holes. It had just a really simple horn. The whole thing was, I mean, there's not even an intake on it, and there's no vanes. What the hell was I doing? I don't even know what I was doing, but that's my first Fusion model, and after practicing and practicing and practicing, this was from like 2020, I think is when I made this. After all that practice, you can make stuff like this. So just stick with it. Stick with it. Don't feel like you're hitting a brick wall. Practice as much as you can. If you get frustrated, take a step away from it. Come back to it later. You know. Yeah, AJ says we all start somewhere. Exactly. We all start somewhere. So, man, that is the second time I've done that. I've just dribbled water on my shirt. Alright, but enough distractions. Let's go ahead and get back to what we're actually working on, the task at hand. Where did I put it? It is probably buried in all my files now. Untitled. There we go. So back to the Model 2. Whew, yeah, my throat's getting hoarse now, man. Been talking so much. So the Model 2 does have like a weird little... Let's see if I can actually go... Let me go in Streamlabs really quick and see if I can actually share this part of the screen. Let's go ahead and window capture. Let's see. I want to see if I can capture this window right here. So just give me 1 second really quick. I'm just working through Streamlabs so I can kind of... I want to be able to pull up this other window too. Let's go ahead. You know what? Let's actually just do this. Let's just capture... Let's just see if we can capture just the screen, because that would probably be the easiest thing to do. Just so you guys can kind of see what I'm working on here. Alright, there we go. So now you guys can kind of see what I'm looking at kind of as a basis for making this siren. So basically I'm just pulling up a couple pictures of 2Ts, Model 2s and Model 2Ts. So I've got a whole bunch of reference files. Did these headphones die? Alright, sorry for that brief little interlude there. Basically, I'm just going through and looking at whatever pictures I really can find. Those are weird. Those are the ones that are in Pendleton. Just looking through, that's a good picture too. I can also go off of, I have a lot of balancing holes that I'm not really going to end up using, but I might as well pull it up. Of course it's on Worth Point. I guess that's all we get. We are not advertising on this. Stop seeing this ad. Alright, so we're going to go off of that picture, which is pretty good. It's pretty good. So we got 4 little webs that are coming off of the edge of the stator. So we're going to go back in here. We're going to make sure that this is tall enough to kind of cover this up. So we're going to sketch, and we're going to make some new sketches here. We're going to do another line. Make sure we're going off this center line right here. We're going to cut all the way across, because I want to make sure that I can capture these little webs. Alright, so now I'm back. I'm going to go ahead and make sure we're going to capture these little webs that I was talking about that are on top of that Model 2, that are actually part of the stator. Do one down there, do one down here, bring it to the edge of the stator, make sure it's mounted correctly. Okay, and now we're going to go up a little bit and give this a bit of some kind of profile. This webbing that is actually holding up this bearing support is a little thick, so I want to make sure that this whole thing is going to be thick enough to actually cover this. So I'm going to imagine this are probably about 4 millimeters up, going off the scale I'm kind of going with, but I'm going to make it 3. Okay, 3 there. Zoom back in. You're going to do 3 there. Oh, come on, select. There we go. 3 there. Done with that. And we're gonna, at the end, we're gonna make all of these convene together. So they're all gonna meet right in the center, right above the hub. Whoa! No, don't do that. Not at an angle, please. Okay. And now we connect them all together. So I'm going to go ahead and go back over here. I'm going to create a new sketch. We're going to make the circle, which is going to basically be our placeholder for the hub, or the bearing mount, I should say. Make sure that these lines are nice and straight, cutting them all across. Make sure they're all connected to the center hub. Okay, another one, and then you'll see once I actually pull these components that you'll be like, oh, it all comes together. You'll actually be able to see kind of what I'm seeing in my mind here. Okay, so now all of those webs are put together. So now we go select all of these, all of these. There we go. Okay, so now let's also select these edges too. I want to make sure these edges are actually in there. Okay, so now I should be able to come in here. Now that I have this little cross, we're going to pull up. Yeah, it's kind of getting there. It's kind of getting there. Let's go back to this. Yeah, they're actually a little bit too thick. Yeah, a little bit too thick. So let's go ahead and go back. We're going to go ahead and change that up a little bit. So these are a little too thick. We're going to get rid of that. So I made these 3 millimeters. Let's go ahead and make these edges a little smaller than that. So thankfully I can just kind of back up to where I was and get rid of all that silliness that I was making. Okay, so we're back to our basically our little compass rose here. We're going to make these a lot smaller. We're going to make these about 2 millimeters instead. Okay. 2 millimeters. 2 millimeters. Here. Model 2T, Model 2 speed run any percent. Okay, so we got that now. Okay, so now go back, make that circle again, same dimension. I think I made it about 8, I think is what it was. Let's make it a little bit bigger than that, makes about 10. 10 would look good. So now we can come here, we actually can just draw these all the way across. I don't know why I was doing it the other way. This will do the same thing, give us the same exact result. Okay, so now we have our little hub. So now, again, this is just a two-dimensional sketch. This is not referenced. This two-dimensional sketch is referenced off of this edge of the stator. So now we have to make this a three-dimensional sketch. It's not just a drawing now. So we come in here, go to press pull again. We're going to select all of the features we want to keep that we want to basically to expand and make three-dimensional. So I have to select all of these little pieces, which is kind of annoying. That's basically just because of the way that I model things in Fusion. There is a way that you can kind of make it a bit simpler, but I don't know that little method because I haven't I haven't been bothered to look at how to do it. Have you ever modeled something completely and then realized you made a crucial mistake early on? Yes, I have. I have done that multiple times. On the Model 120, for example, this little on the Model 120, there's actually supposed to be webbing right here on this bottom little flange that actually supports this the start of this diffuser in here. There's supposed to be webbing that goes against it. And if you look on Aaron's actual Model 120, you can see it, but because of where this is placed and how this is all profiled already, there is no way in hell I could make that add that little webbing to it after I did all that. I mean, there is a way I can do it, but it would take like way too long to try to do it. But yeah, I've made that mistake multiple times before. Oh man, what? It deselected this because I was looking at another window. But yeah, I made that mistake basically like after I had already modeled like the entire thing, and I'm like, man, I'm not going back. I'm not going back to fix that little tiny detail. And Aaron was like, oh, Aaron was like very specific about it too. He's like, what about this? You forgot this little part. I'm like, yeah, it's not that important, Aaron. I'm like, don't worry about it. So we're gonna raise this piece up a little bit. I'm gonna say about 3 millimeters. 3 millimeters seems fair enough. That seems fine to me. So we're gonna say that's good. And if I need to actually print this as its own separate thing later on, I can actually remove. I actually can use the split tool. Come in here, find this body, find a splitting face I want to split on, and I actually can cut that piece back off again and make this its own separate thing. But I'm not going to do that. And I got an error message. That's cool. So I know there's a little bit of a profile. A little bit of a profile on this little edge right here that I have to try to capture. So I'm going to try to do that first. I'm going to try to capture that little tiny little edge. So let's go back in and we'll fix that again. So there's a little edge that kind of comes off. We're going to go back to my favorite tool. We're going to go chamfer. We're going to chamfer all these edges. We can kind of just do it at once rather than kind of splitting it all up and then doing a pattern. So we're not going to do a pattern. Because with chamfer, you can actually select all the edges you want to chamfer first. Keeping it at distance and angle because I want to make this a very specific kind of dimension. Whoa, I don't want to taper that far. And we'll just kind of adjust until it looks about right. Of course, it's going to be fighting me now. Let's do 16, 17, 18, because there's a little bit of an edge on the Model 2. There's a little bit of a rounded outward edge. Now, do I want to do that, or do I want to just leave it and then round it over later? I think... No. You know what? Never mind. I'm not going to do that. I want to go and actually... I want to actually capture this little round portion. There's this little round profile that's right there that I really want to kind of capture first. That's along this edge. Let's see that little sweep. I want to make sure I get that. So, and then this chamfered edge ends about right at the center point of where the actual opening for the rotor starts. So I'm going to go ahead and change this up a little bit. So let's go back. Let's see what we can do about that. So, and before I do that, I'm going to go ahead and have to take a quick little break. I need to go to use the bathroom. But when I come back, we will continue on with making the Model 1, the little mini, tiny little Model 2. Sirens and Aviation and more. That looks freaking awesome. Thank you, man. AJ says, when I made my first 3v8 chopper in Blender, I accidentally made the entire thing oval-shaped with an off-centered hub. Yeah, I don't remember how Blender does it, but does Blender give you actual like reference points, like when you're making things? For example, they give you origins like this, if I was to move over here, I can, this is my origin point on the bottom, or I can look at it like that too if I want to. But like I have this, basically this individual origin point. Does Blender do the kind of like the same thing and give you these grid lines to kind of work off of? I don't remember how Blender does it. Again, I used it so long ago now, but I'll give you another kind of cutaway image, something you guys can, some more eye candy you guys can kind of look at while I'm going to the bathroom. All right, I'll be right back in a second. All right, sorry about that, guys. Quick little bathroom break. Quick little bathroom break. Let me pull up Streamlabs really quick again. I want to see what you guys are actually looking at. Okay, cool. So I'm still on here. All right, so let's go ahead and go back to the model we were working on. Oh, we got some feedback. Okay. So, we left off, we were talking about making this little kind of curved little sweep that I was showing right here. Go back again so I can show you again what I was talking about. We're gonna model this little kind of curved edge right here, and I think the only way I can really feasibly do that is by actually coming in here and making this taller using the offset face. Actually, I should be able to just kind of offset this entire thing. Let's see if it. Whoa! Whoa! That is not what. Oh my God! That is. Fusion can get dummy sometimes. Let's go ahead and bring that right back where it was. So I want to see if I can select specifically just that edge. I don't think it's going to let me do that. That's really kind of infuriating. All right. Well, if I can't do that, then I'm just going to have to model another little circle around here so I can basically make this ring over again. Okay, so now I have this ring, finished sketch. Okay, so now it should make these its own little isolated things. I think it just did. Cool. Go in here, press pull, press pull. So now that it's its own little sketch, I should be able to bring that up. We're going to join those together. We don't want it to get cut. Okay. Okay, we're gonna make that. Go back, press pull, press the whole thing down now. Make this a whole lot thinner. So now I can actually, so now this is offset faces detecting this as its own thing. So I'm gonna go to fillet. That's gonna give us that round little profile. Select that. I'm going to select all of those little edges I was talking about that I want to fillet, so we're going to make sure that we can have all those captured, so that when I go to actually cut those, it will capture all of them rather than me having to go back and actually use the pattern tool to make those again. So this is kind of the tedious little part about doing this, is just going around and selecting those little edges. I think I got all of them. 1, 2, 3, 4, 2, 3. I missed one. I missed one little edge. My cat's playing with her cat toy now. Okay. So now, watch this. This is some wizardry. I love that Fusion is able to do this kind of stuff. You can just do it all at once. Okay, there's that round little profile that the Model 2 has. And, oh, did I have all that invisible this whole time? I'm so sorry. I was not paying attention. But basically what I had done is I selected this, I shortened this whole thing down. Whoa! This whole thing's wigging out. That'd be a really, really cool Model 2, though. Yeah, so by allowing this to... My cat is still playing with that. What are we doing? Right now? Really? So now I actually can select that. So we're going to make this just like that, because the Model 2 does not have a huge little profile on that. See, that's not super big. It doesn't extend out that far. So we're going to put it about right there. And then now my cat's trying to eat the cardboard from this box that's right here. I swear to God, if you have animals. Okay, so now I'm going to come here. Is it still on that screen? Yes, it is. Get rid of that so you can see what we're doing again. So now we're going to come here. I can either make this tall, make this a bit taller again, and then fillet back basically from where I was. But I still have to capture that little bit of an upward profile. So make that about that thick. Yeah, that looks pretty good. This is kind of the part where I start getting stumped because the dimensions get weird. So we're going to do another circle that size. A circle to this outer edge of the stator, so I can cut these and make them their own individual piece. Finish the sketch. So now that sketch isolates this little cross from the rest of the stator. Go here, go to press pull. So now I can make just this cross piece a little bit taller. But I'm also at another impasse where I don't want to bring up the entire thing. So I want to get just this edge across, so that I can make this now, this little raise that's on there. So how am I going to do that? So I think what I'm going to do is I'm going to go here. I'm going to create another little circle. Actually, no. No, I'm going to close off right here, about where that little chamfer kind of ends. Go back, go to solid, go to this, and wow, Fusion was having a stroke there on that. It's still doing it. Okay, so I'm not gonna do a circular pattern, I guess. Never mind. Never mind. Okay, about how far from the center point is that? 16.08. Let's do that. So 16.08. 16.086, which is a weird dimension, I understand, but that dimension is just weird because of this chamfer that I have right there. So we're gonna kind of ignore that. We're gonna go 1608.6 again. .086 puts us again right there. Now I'm basically just using these dimensions to basically kind of give me a little bit of a milestone as to where I want to place this little cutoff point, so I can make those little raises a bit more specific. So now I can pull up just this cross. Make that just a little taller, about like right there. That looks pretty good. Join that piece. So now I have this very odd looking cross. But now go back over here, go to chamfer again. We're going to chamfer those edges that I just placed. And oh, distance and angle. Come on, where's my angle at? Wow, that looks goofy as hell. I'm not gonna lie, that looks real goofy. Let's go ahead and look back at our reference image. Huh. Well, I guess the way that they did it, that Federal did it, is that you're actually chamfering this whole thing, which is really kind of annoying and not really all that practical for the actual printer to try to make. So we're not going to do that. Yeah, we are not going to do that. That's a little crazy for the trying to expect the printer to do. Man. No, we're going to have to go back. Aw, man, we're going to have to go bald. Okay, we're going to do this instead. Okay, so we're going to have to make those chamfered edges just a little smaller, because that's going to be way too big if I try to just do that as it is. So, fillet. I keep saying chamfer, and I mean fillet. Fillet. This time I will cheat because it's a lot simpler than running around and actually filleting each individual one. So we're going to do about maybe that much of a fillet instead, which still generally kind of captures that same little profile. And we're going to do that. Okay, so now we can go back in because I'm lazy and I don't want to go and select all of them all over again. You select just those profiles, go along this axis, do it 4 times, and it ignored me. Hold on. 1 second. Sorry about that. I had to kind of like goofy arm model too. Yeah. Oh, is the stream broken for me, or is it just stuck on the browser? Yeah, I had it. I accidentally had it kind of stuck on the browser for a second. That was my own fault. I also had to kind of adjust the cats because, of course, every one of my cats is in this room right now for some reason. When the Model 2? When the Model 2? Yeah, big federal bruh moment. Go back and make this again. Come on. Work with me here. Just want you to capture those. You know what? Let's get rid of features and make it faces instead, so it selects just the face. Sometimes Fusion can be a little wiggy when it comes to doing that kind of stuff. No, not features. Let's do faces, specifically faces. So it should capture just those two faces. Let's go along the same axis again. Times 4. There we go. That's what I wanted you to do. Okay, so these are a little bit smaller now. A little bit smaller. Okay, so now go back, make that same sketch again with the circle specifically, and it should be able to find that edge. Perfect. So it found the edge of this when that chamfer basically stops. So now I have specifically just this little circle, and well, no. Okay. Hold on. I know how they modeled it. I know how they did it. I know how they did that. So they want to go up about like that, out that thick, and then they chamfered the whole thing down to that. Yeah, I bet you that's how they did that. So now we'll chamfer this. Yeah, that's how they did that. Okay, that explains why the angle was so weird. Don't fight me, man. That looks better. That looks a lot better. Yeah, that's how they did that. That makes more sense. Yeah, that looks a lot better. Okay, that makes a lot more sense. I was trying to like work it out in my head as to like trying to figure out exactly why that profile kind of looked the way they did. Okay, so now I've kind of captured the general shape of the stator now. That looks pretty good. Yeah, that looks pretty good to me. So now, I know they also have this little thing right here. My cats are being really annoying right now. Man, I'm getting hungry. It's almost around lunchtime now. Demetrius Padilla. I can't remember, but I heard that Eden was planning on selling his Model 2s. I didn't know he was even making many Model 2s. That's kind of cool. Yeah, this was, someone had suggested like early on in the chat to try making a Model 2 or Model 2T, so I'm like, okay, that sounds kind of fun. It'd be kind of a simple little laid back kind of thing to model. Alright, so let's go ahead and get back to this where we're at. So we have this profile captured correctly. Now there's a little bit of the detail stuff that I want to add now, because there is a bit of a thing that goes on with these. So normally this portion is actually somewhat indented. I don't want to move that. Don't move that. No, go away. I'll move just this, please. This has a little bit of an indent on the real one. There normally is a couple screws that are sitting around right here. So I'm going to make just a circle. Make a circle there so I can see kind of where I want to be at. And then make a circle. Another little circle, basically to make, basically just modeling a screw. Right there. Oh, my cats are being so annoying right now. So now I have this little circle. I'm going to pull up this little circle a little bit. That looks good. That looks good. We're going to join that. Ah, of course it caught that little stupid edge, really. There we go, get rid of that. And then, what kind of screws did they use? Were they flatheads or were they Phillips? Let's take a look at that really quick. I think they were probably flathead, judging by how old it is. Yeah, they're flathead. Okay. These little, tiny little flathead screws. There's 4 of them that go around this entire thing. And I have them on the wrong edge, of course. So, we're going to go ahead and move that. Good thing we're early enough into that so that I can actually go back pretty quickly and change where it's placed. Okay, so they placed these little flathead screws about right there. So we're going to place that, press pull, bring that two-dimensional body into or a two-dimensional sketch into a three-dimensional body. I'm going to join, get rid of that little ring again. Okay, so now I want to make this look like a flathead screw, so we're going to make a line. It's be pretty simple to do this. You just go in here, find an edge, cut across, find another edge, cut across, take this, press pull this center portion, make it look like that. I'm going to cut that, we're going to cut a little bit deeper than that, cut that, select this edge, select this edge, and then chamfer both of them. Actually, no, let's do, no, we're not going to chamfer, we're going to actually, where is it? Where is it? Not chamfer, I don't want to chamfer that edge, I want to find something else. Fillet, there we are, fillet. We're going to fillet this, and it's going to make this whole top of the screw head round. That looks close enough. It's basically only one of them anyway. I had one more error, it's annoying. Go back over here, make another pattern. Basically make this whole thing, select this whole thing, select an axis, we're going to do this axis, we're going to make 4 of them. And it didn't capture the actual top of the screw, that's cool. That's another one I was saying, like there's like little quirks of fusion sometimes. There we go. Now I selected all of them, so now it should actually all be there. And there we go. And there are some screws. So you know what? Because that irks me that they're all like perfectly lined up. That's assuming that you like perfectly tightened every screw to look like that. Like you're some bozo with some free time. We're not going to do that. So we're going to, of course, I made it its own. I gotta make sure these are their own entities. So is this its own entity or is this part of this? Oh, it's a feature. So we're actually have to split this. So split this body, splitting tool, we're going to split off this top face, so it basically will give me this as its own separate thing. So now this little screw is back to being its own separate entity, so I can actually get rid of that screw if I wanted to, since this is its own separate body. So now we should be able to go in, and I should actually be able to just do circular pattern again. Select this whole thing, not that, or that. Oh my god, Fusion, you can be such a pain. Selecting things I don't want you to select. Select that, and select that. Okay, so it should have selected the whole thing now. So now I can go around that edge. Basically, so I just made clones of these pretty much. And now I should be able to go in here and rotate an individual one. Oh, why are you doing it across that plane? There we go. Eh. Yeah, we'll make one screw cockeyed. Why not? Yeah, because I can't select the rest of them. That's annoying. Yeah, I'll make one little screw look a little cockeyed to the rest of them. Why not? This little indent is not that deep, though, so we're going to bring that up a little bit. There we go. Bring it up just a little bit. So there's basically a really, really simple head of a Model 2. 5 ports, of course, open on the bottom. And now we'll go on and continue on, make this a little bit deeper so I can have a bit of space, so I can have some play in the motor here. So we'll make that a little bit deeper, just like that. So now I can come off of this bottom face. Or no, not press pull, not press pull. We're gonna make another sketch here. Same dimension as that. We're gonna bring this out a little bit so it has a little bit of a lip because the stator has to mount to something. Now we're getting into the speed running kind of part of this because this is all easy stuff now. Bring that down 1 inch, so now I basically have a stator cap like that. Get rid of the analysis. So there is our Model 2 rotor and stator. Alright, so let's look at some of the chat now over here. AJ says, I'd be worried about the rotor given that I'd be spinning at around 6,000 plus RPM. Agreed. I might boot up my laptop and download Fusion, or however you say it, LOL. Sirens, Aviation, and more. Yeah, Fusion, like I said, just go look up Fusion 360. It's called Fusion 360, and you can get the hobby version of it. If you look at the prices for Fusion, they sell it is insanely expensive. It's like $400 I think a year. But don't go for that. That gives you like simulation and a whole bunch of other stuff that you're really not going to use if you're just modeling sirens. So don't go for that. Go for something. I think it's literally just called the hobby version. When you pull up the thing, you'll have to make an account with Fusion. So basically, which trust me, it sounds a little off-putting at first. So you have to make your own Fusion account. But Fusion allows you to save all of your files on the cloud. So say if you're at like a library or something like that, something that has a makerspace, if you don't have a 3D printer, you can pull up Fusion on that computer and then sign into Fusion, and all of your files will be right there. So you can work on them at a different computer, which is really, really convenient. I like that. That's an ability. Like Fusion, I had on my old computer, and my old computer was like I call my crap top because it literally couldn't run anything. It struggles opening up web pages now. But I could take all the files I had made on that and bring it over to my new computer with no problems. It's really, really nice. But when you're on the site, actually, let me show you really quick. I probably can actually just show you right now how you do it if you want to get Fusion yourself. Let me transition over so I can show you my web page right now. So if we go over here and we go to Fusion 360, let me look it up. So you're going to click on this one, which is, it's made by Autodesk, of course. You can download the free trial. You don't have to do that. But if you scroll all the way to, like, almost basically to the very, very bottom. Wait, where is it? Where is it? Where is it? Where is it? I'm not going to sign in because you don't need to see that. Paid monthly. They have a lot of these things, but I'm not going to be buying that, man. That's a rip. That's a rip. Where is it? Where is it? I know it's somewhere on here. It's somewhere on this webpage that you can go through. You can even look it up on YouTube on how to get the actual free version. But trust me, you can get Fusion for free. And like I said, it is a very, very powerful tool. That looks like a HOR style rotor. Where is it again? Okay, we get better, more of a profile view here. Go back to working on what we're doing. Okay, so what else do we have on the chat? What else is on the chat? So let's read a little bit more of the chat. Give you some more stuff to look at. My cat is being so annoying right now. Okay, I might boot up my laptop and download Fusion. Demetrius Padilla, I didn't think it was possible since he uses shaded pole and split capacitor motors. which are way too big for the scale he builds them in, which is like 1/5. Yeah, he uses 1/5 scale. AJ, he uses Capstart. He used Capstart for the 2T22. He could possibly use very small repulsion motors. They don't make repulsion start induction run motors anymore, if that's what you're referring to. Repulsion start induction motors were made by GE and Century. Those repulsion start induction run used brushes to basically to start the motor, and then they dropped out when it was running. Use to start capping the 2T22A and then B&M. Yep. Actually found an eBay listing with the exact same motor he uses. Well, you don't actually need to find on eBay. You actually can just look them up on, like, say, like Dayton or like other places. Like the motors he typically uses, that Eden uses, are like this. So like this, I have this motor because I'm going to be using this for a prototype. I'm going to be using this for a prototype. What was I going to make? I was going to make, I think it was going to be a Super Cyrex. The single horned one that just kind of rotates around itself and has the big dome on top. But yeah, he uses. You can get these on Dayton. You can get them on kind of like anywhere you really want to. Basically, you just have to know what the frame size of the motor is. That's pretty much it. It's not like it's some kind of specific motor. Is the software you're using called Fusion 3D? No, it's called Fusion 360. Consolidation 1282 looks nice. Demetrius Padilla, I'm gonna be honest with you. I think you would be a great Roblox siren modeler with Blender. As I said before, man, I am absolute dog with Blender. Agreed. AJ said he doesn't use Blender. Wonder if Fusion would work with Roblox. It probably would work with Roblox because you can actually export these models that you make into other programs too. I meant for Roblox. No. The Model 2 looks great. Thank you. It's taken some time. I've definitely been doing a lot of talking and not a lot of modeling. Hold on, let me let my cat out right now. She's kind of getting a little annoying. Apologies for that. Yeah, she was getting a little worried just because she's just stuck in this one room with me. She's kind of wants to go outside and go to the bathroom. Yeah, I have my other two cats in here too, but they're pretty complacent. They don't really get too freaked out. All right, so continuing on, what should we model next? We're going to need to have to get this horn done for this top. So I figure we can probably start working on that as well. So the horn for this Model 2, just like that. It's a pretty simple little thing. It's not that complex. Let's go on to Worth Point again. Worth Point is, honestly, I really think Worth Point's really annoying because then you go looking for a siren on eBay that you're like, oh cool, I can get like say a Model D or a Model L on eBay, and then you find out that, oh no, this is a listing from like 2 years ago that Worth Point just for some reason still has on there. Get some better pictures here. More of a side profile. This little flange we'll add later on. That's going to basically just sit right on top of the... Basically it's just going to sit right on top of this little lip eventually when we're done. That's basically just a little piece of sheet metal. But the horn is really the interesting thing I want to kind of get to now. So to do that, again, Fusion has a lot of really cool little tools you can use, but we're going to go here, do construct. We're going to make an offset plane. We're going to offset this plane based off of this very top little portion. I want to see exactly where this is going to end up. So we're going to move this plane down a little bit, probably about like 4.5 maybe, about 4.5 mils. Yeah, about 4.5 mils. That looks pretty good. It's about 4.5 millimeters right there. So now we have a plane we can construct on. So we're going to select this plane, we're going to draw a sketch on that specific plane. So even though it looks like I'm drawing on top of the very top of the bearing cap for this motor, or the siren, I'm actually drawing, if you look at where my plane is, where this grid line is, this grid layout is actually about, again, about 1.5 millimeters below this bottom lip of this stator. So now we're going to go back up, select this. We know roughly about how big the stator is, and that's this line right here. This other circle is going to be deceptive, but that line, this circle is not actually the circle you want to be working off of. You want to be working off of this one, because this is the true edge of the stator. This is the edge of the bottom of the stator. So we're going to be coming off of this. Remember, you have to maintain tolerance. So this horn is going to be a separate piece. This is going to be a piece that's going to be basically glued on top of this, because I don't like using fasteners. Fasteners strip out, they don't grab onto plastic very well. So I use CA glue, cyanoacrylate. So this whole piece right here is 44 millimeters. We're going to do the same tolerance that did with everything else. We're going to do 44.5 to give us a little bit of space kind of coming off of that. That should be plenty. If anything, that actually might be a little too much. Let's go back. Let's go back a little bit. Now, if I know this is going to be printed with FDM, this is going to be, I know my tolerance for this because I've been playing around with them for so many times. My tolerance for FDM printers to make them nice and tight but still able to fit together is about 2.5. So we're going to do a tolerance of about 2.5. And we're going to add the thickness of the horn. We're going to make the bottom, this is what, 44.25. We're going to make this, let's do 46.25. 46.25, which means that the thickness of the horn is going to be about 2 millimeters. We're going to press pull that little ring, which is going to come up off of the bottom of the stator, about right there. I'll make it a little bit longer than I have to. Make it right about there. Make sure that it's a new body, so it's not something else. And now what I'm going to do is I'm just going to get rid of this. So I'm going to get rid of the rotor, get rid of the stator. Why is that screw there? Hold on, let's combine this really quick. Okay. Alright, so that simplifies it a little bit. So now, come back over here, we're going to create another sketch. Because we want to sketch off another face. We're going to reference this new component we're going to be making. This new shape, basically. It's still part of the horn, but we want to make this its own little shape so we can kind of move things around later on. And we can also change things later on. So we're going to make this its own little shape. So this is sitting, that little two-dimensional sketch is now sitting on top of that three-dimensional one that's on the bottom. So see how it looks like that? I can make that little ring disappear, but that sketch stays there. So now, we kind of have this idea, so we're not going to be done with this yet. We're going to construct another sketch. We're going to finish that sketch, we're done with that. We're going to construct a new one, another new offset face. And we're going to say this is going to be, about how tall is this horn? How tall is this on the actual siren? It's pretty tall coming off of the, that stator. So we're going to make this a little tall. Make that about right there. That looks pretty good, about 30 millimeters off of the stator itself. I can add the stator back so I can kind of see about where we're at. 30 looks actually a little too tall. Let's do about, you know what? Let's keep it at 30. Let's keep it at 30 for right now. So now we got this other sketch on top. I'm going to create another circle. Now this is going to be the profile of the top of the horn. So basically how wide open the horn is going to be. So we're going to make that a little big. Now, this whole thing's going to look really funky. This is kind of the thing where it gets to just making it look generally all right, like as close as you can get it, very basically. So that's actually a good reference picture. Is right there on the top. That's the motor brushes. That's a pretty good image we're going to go off of right there. So now we're going to go make that disappear again, go back to Fusion. So that's a pretty good ballpark for what we want this to look like. I'm going to keep switching back to look at that image a little bit. Yeah, that looks pretty good. So now that we have this profile, we're going to make this other piece 2 millimeters off of that, because we're going to make the whole thickness of the actual horn, like the thickness of the material, 2 inches, or 2 millimeters. So if that's 90 millimeters, we're going to just go ahead and come jump in here and go 88. That makes us have another ring right here. And now is the fun part, which is a lot easier than I think most people think for making horns. We're going to go to the loft tool. The loft tool will draw a loft basically between two sketches. So we've got this, now that we have this sketch that we did on the bottom, remember? And we have the sketch we did up here just now. So we're going to connect these two sketches. We're going to select these profiles. We're going to select these profiles. We're going to select these profiles, Fusion. Okay, there we go. And boom, it makes a horn just like that. So it's pretty quick. It's not, doesn't take that much time to actually do that. But as you can see, the horn is actually a full thickness thing. There's actually nothing in between. There's no space. So in order to add space, we come up here and we go to Shell. And Shell will basically allow you to cut out material from the inside that keeps the profile of the outside wall. So it's just like making a shell. So we're going to select, we want to shell this. We know our inside thickness. We know we have set it for 2 millimeters. So we just select 2 millimeters. Now that actually looks a little thick. Why does it look that thick? That looks crazy. That looks dummy thick. That is a really thick horn. That is not as thick as, that is not really as thick as I wanted that to be. Let's make this about 1.5 millimeters. Let's see what that looks like. That looks a bit better. That looks a bit better. Let's do 1 millimeter. Let's make that 1.5 millimeters. That looks pretty good right there. So 1.5 millimeters. Of course, it will leave this little dish at the bottom, but in order to get rid of that, press pull. Whoa. Actually, we need to sketch that. So just go here and make a sketch. Basically, just trace out that. Then press pull. What are you doing, Fusion? We're going to press pull just that. Thank you. And get rid of that. So we're going to cut that out. And now we have the top cone for the Model 2. Now the Model 2 does have this little tiny ring. Let's have this little tiny ring that goes around this top little rounded over edge. Right there. So what we're going to do is we're going to go back into Fusion. Now we reference, we have that. We have to deal with that little kind of ring that's up there. So now this is one of those things where this is kind of a detail issue. You can either add this detail, which will actually make manufacturing a little bit more difficult later on when you actually try to print this piece, or you can leave it out. You can leave it out. It's something that people really won't care that much about, which is why the Model D, for example, when I made the mini Model D, didn't have that little ring that kind of goes around it. But if you wanted to add it, here's how you do it. So I'll go ahead and show you how you do that. So you go down to Torus. Torus allows you to add a circular little ring. We're going to go select off of this face. You select how big you want to make the torus. We're going to make it about that big. That looks gigantic. You're basically making a gigantic donut. We're not actually going to do that. We're going to shrink this down a little bit. And then move it in. So now if you wanted to add that little tiny lip around that edge, I selected cut. That is my own fault. I did not mean to select cut. Go back and do that again really quick. It's not that hard. Again, Fusion makes it really easy. Okay, go in there, just like that. We're going to shrink down this. It's way too big. Now it's way too small. Just to cover up that little edge right there. Front, please. Front, please. Thank you. Okay, so now we're not going to cut that. We're going to join that. So that's going to make that little tiny lip that goes around the edge of the top intake cone for the Model 2. And that's what it looks like. Now, I normally wouldn't add that little lip because it adds to the difficulty of printing, because the printer actually has to try to model that little round lip on the edge of it. And it doesn't lend very much support to the actual build platform, so there's not very much that the printer can actually grab onto when it's trying to make it. So I personally just get rid of it. I don't actually want to keep it there. So I'm just going to undo the torus because I'm not going to actually keep that because there's no need to have it on there for the model that's going to be this small. So we basically have a majority of the functional parts now completed. So now it's when it gets into using this is the part that kind of gets into using the calipers a bit more that I had showed very early on when we started streaming, of using the calipers to actually measure the dimensions of the parts you're going to be using to make this siren. So this motor is the motor I have now chosen. This is the motor I've chosen to spin the rotor in the siren. So I have to make sure that I'm engineering tolerances that are going to be accounting for the size of this motor so that this motor can actually slide into the plastic pieces, that the rotor will grip onto the motor shaft properly, and it's not going to be too tight or too loose. And again, tolerance, tolerance, tolerance. It all comes into how close fitting the parts are for the parts that you're printing. So in this case with FDM, if I was to pull up, say, my slicing program, I can do that really quickly. Let's see if I open up, let me open up, you can see my background for a second. I don't want to enter my password. Why does it always open up that? That's so annoying. If I open up my slicing program really quickly, see if I can, I'm going to add another source right here really quick. If you had enough filament, you could make a full-size Model 2 or Model D. Yeah, I kind of can. I kind of can if I stay within the constraints of the build volume of my computer, of my printer. But yes, I could. Okay, let's name this Prusa really quick. So I'm going to add that as a source. All right, let's look for that window, Prusa slicer. There we go. So here's my slicing program. This is the program I use for making my sirens, basically. So if I was to say import really quickly, let me go back to Fusion. Go back to Fusion. Where's Fusion? Let me make Prusa disabled. Okay, so here's Fusion. So say if I really wanted to make this part right now, let's say I wanted to make, get rid of the horn. Say I want to model the stator. So I can go into Utilities up at the top, select Make, and then just highlight the stator. Now it says send to print utility. It defaults to Cura, which I hate Cura because it's such a just backwards freaking program for doing this. So I basically just export it to my own thing. So I'm going to come here and say stator, give it a name, Model 2. Okay, so it's going to save this document. Let me save this to my desktop really quick. Let's go to 3D files, make a new folder. I have a whole bunch of stuff in here. Model 2. Okay, save it there. So I'm going to save that to a file, to a folder. I'm going to go back, I'm going to open up Prusa again so you can see what I'm doing. Okay, so now that I'm in Prusa Slicer, I can go ahead and grab that file that I just made, and I can drag it into Prusa, just like this. And now that is how small that piece is on my actual print bed. So there it is right there. Now the one thing that's really annoying is that I've got this piece up here that's essentially is just flying. That means that the printer is going to have to actually model that in the air, but I can also go in here and make sure I've got supports. But if I had no supports there, then this is essentially what the piece would look like. But there are parts that are floating, which are highlighted in blue, which the printer is basically, the print head is printing in free air, so there's nothing for it to actually lay down across, which is why we always use supports. Well, it's why most people use supports, but I try to engineer my stuff to have as little supports as possible, because supports add material that's not actually going to be functional, and it adds a lot of work for stuff that you actually have to like rip out later on once you're done modeling it. So it's something that I try to avoid like the plague as much as I possibly can. But for weird stuff, like I said, with this horn, for example, if I had that little lip on there, then the actual contact area, which is way down here, so here's the actual print bed itself, the actual contact area, if I had just that little tiny rounded over little spot, go down and slice through all the layers that's printing, then it would have a very, very small little contact patch, basically about this little single line thick that is trying to build all of this stuff up on top of, which is why I try to avoid making rounded things that are going to be FDM printed or even MSLA printed, because they just really, really struggle to do that. Which is why if you look at, like on my previous videos, if you look at the WPS 2802, it doesn't really model that like smooth transition of like the very top of the siren very well, which is why I try to avoid doing stuff like that. Let's go ahead and go back to Fusion though. Let's go back to the task at hand here. So that's just something you want to kind of consider when you're modeling these kind of things, is just the restrictions and the constraints of the printer itself. I see a couple people in the chat are saying that they also dislike Cura. Yeah, I know that, like I said, I know that BSP uses Cura for some reason. I don't know how he deals with using Cura. It is just such a frustrating thing to try to work with, which is why, like I said, I try to avoid it as much as possible. Oh my god. Close this window, please. Thank you. Okay. But that's basically, it's Cura is cursed, man. It is cursed. I avoid it like the plague. If you can, because Prusa Slicer, this slicing program that I prefer, is free. You can get it. You can set up different constraints for like what kind of printer you're using. You can change things to kind of like customize it. It's a lot more user friendly. Cura is very like bonehead tier level stuff. Whereas like Prusa Slicer, you can do a lot of complex things with it. Like I can go in here, select different prints, different print constraints, speed, skirts and infill, layer height, stuff like that. It's really easy to work with. It's really, really intuitive. Okay. No. I want to go back to what I'm working on. Thank you. Triblaster eating candy. LOL. Halloween. Yeah, I haven't gotten anything yet. We're basically just gonna be going out to dinner, me and my wife. Hi, GVAC. Oh, so you're talking about my hat? Yeah, I do heating and air conditioning is actually my daytime job. I'm a HVAC tech. AJ, I'm glad I'm not the only one that dislikes Kira. Yeah, it's like I said, it's a really backwards way of doing everything. I completely screwed up my print twice. Yeah, that's believable. I've had a lot of trouble with it. Consolidation 12 to 82. I'm not eating anything right now, but I will be very soon. Justin Lin, North Mariana Islands have modulators. Yes, they do. Yes, they do. As does Puerto Rico. I believe Puerto Rico has a couple modulators too for hurricanes. Alright, so I think, guys, I'm going to be cutting this off pretty soon, because I do have a day, I do have a life. I kind of got to get around and get some stuff done. I'm getting kind of hungry too. It's, well, 12:59, about 1 o'clock, so it's almost lunchtime for me. But, yeah, I hope you guys did enjoy the stream, though. I hope it's, I don't know, it's kind of a new thing I want to try out. I just want to see if people, if they kind of got a good feel for it. And also kind of just displaying how these sirens are kind of made. So it's not necessarily just like this real simple thing where I can just kind of like just knock one out. There's a lot of work that kind of goes into it, a lot of fine tuning. And this is just a simple model. This is just a Model 2. So like, I mean, it's taken me what? Almost 3 hours to get just this far. So I mean, I guess you guys can really kind of imagine, you know, how long it takes to model something like this. Like this takes multiple days, if not weeks, to model. So, but I wanted to kind of see what you guys thought about it, and just kind of I don't know, just see what goes into making these models, because I know a lot of people, they see the models, they see people test them, they see people play with them, but they never actually get to see how they're actually made. Um, and for any of those that are wondering, Eden uses SketchUp. He uses SketchUp, which used to be owned by Google. It used to be a free a free CAD program, but they ended up like wanting to charge money for it. The SketchUp charges a lot for the stuff they make, and it's just, I don't know. It's not for me. It's not my kind of program. I've always had a lot of Autodesk. Autodesk was the program I used in high school for my robotics program. It was the paid version of Autodesk was what I used in engineering in college, and it was just, I don't know. It was, Autodesk was what I learned, so it was always the easiest thing to kind of work with me. I tried Blender, I tried SketchUp. They just didn't work. They're always just really goofy with the way they have like specific things laid out, and like they're just, SketchUp and Blender are more made for like modeling. They're not necessarily made for like engineering. When it comes to like engineering stuff, Fusion and Autodesk are a very, very powerful program to use. But I hope you guys enjoyed the stream. I know it's been a long one. If it's been about 3 hours now, I hope you guys really have had just a lot of fun. It's just been I think I just lost brain cells. What, you don't like that I'm using Fusion? I know a lot of people have their opinions on what kind of CAD program. It's like Apple. It's like Apple or Samsung. People have like their own little the way they like to do things. I don't know, but yeah, leave your comments down below. I guess the comments are all kind of in here, but I appreciate you guys kind of joining along for the ride. I'll definitely show probably a bit more videos in the future on my channel of some of the progress of what this has kind of gone into for the Model 2. And if you guys would like to see more like Fusion content, of even if I'm not necessarily doing a stream, but of doing like an actual video on how to do certain things in Fusion, let me know. I'd be glad to help. Yeah, that's pretty much about all I could really say. Hope you guys have a good rest of your day. Hope you guys have a happy Halloween, and get a lot of candy, get fat. I definitely know I'm going to be feeling sick pretty soon with all the candy I'm going to have. And yeah, just enjoy making sirens. Oh, Liam Aerate Siren. I remember, yeah, he was asking about making a 8 horsepower gents a while back. But I don't know. This is what I'm making today. But maybe at some point I'll make an 8 horsepower gents. But yeah, hope you guys enjoyed watching the video.